Hi everyone, welcome back to our lesson. Today what are we going to do? We are going to start with you physics quick revision for mechanics. First of all, for mechanics, what definitions we have? So we have our list here. We should memorize them all, nothing to do. So for our final exam, we should know all definitions: friction force, normal force, frictional force. As you know, we have two types of frictional force: coefficient of friction, weight, and more. So we have these definitions. Please study, please try to memorize them all. Today, our quick revision, so let's continue. And Newton's first law, second law, third law, and Newton's law of universal gravitation. So we have these definitions. Please study, please try to memorize them all. When you check past papers, you see some kind of definitions mostly coming. For example, Newton's first law, second law, third law, mostly coming. Just remember, you can continue with definitions, but we should know all definitions. As you know, for this topic, 1 or 2 definitions coming with 2 marks for mechanics. All right, all definitions here, please study them all. And then what else we have? Cases for calculating the normal force and frictional force. How we are going to calculate normal force? First of all, let's remember how we are calculating normal force. And by using normal force, we can calculate friction force if you have friction. If you don't have friction, you don't need to calculate, of course. So let's continue. Let's check now. First case, you have only one object, and then how can we calculate our normal force? As you see, normal force is equal to gravitational force, but we are using Newton's first law, even second law. Which one we are using? Newton's first law, of course. For normal force, Newton's first law. F net for perpendicular equals 0. And what we have, if I say up is positive, down is negative. So normal force you can show with Fn or just n. N minus Fg equals 0. Normal force is equal to Fg, it means m times g. So just remember, if you have one object, normal force is equal to mg. We are going to just use like this, but it's coming from Newton's first law. I hope it's okay. When you come this side, same calculation step by step, and finally you are going to get normal force equals m1 plus m2 times g. So this is our normal force with 2 objects. And we are going to calculate all of them normal force. After that, we are getting friction force. So what we have now, apply force this way. Now case 3 with apply force. As you see with components, we are getting, how can we get Fa plus? So let's learn how we are getting component of force, components of a force. So we are using F apply parallel. For example, we can use F apply times cos alpha, and then for perpendicular, F apply times sine alpha we can use. So as you see with normal force we have up. So as you see 2 forces, you can use Newton's first law one more time. F net, because object is not going up and down, perpendicular motion is 0, acceleration is 0. So you can write normal, let's say up positive, we are choosing our direction, up positive normal force plus F apply perpendicular minus Fg equals 0. So you can write normal force like this. Normal force equals, let's write nice one. Normal force equals, you are just taking F apply perpendicular Fg other side. Normal force equals Fg minus F apply perpendicular. So what we know, Fg is equal to m times g, and minus F apply perpendicular, what we said, F apply times sine alpha. This is my normal force for this case. And then when you come to other case, next one, now as you see direction of applied force different. Now as you say, if apply perpendicular, just opposite direction of normal force. So you can say it is helping to gravitation, but if you start from here and carry on, you are going to get your normal force equals m times g plus F applied times sine alpha. I hope it is clear how we are getting normal force for each. I hope you are okay. And then for inclined system, case 5. So how we are going to get normal force? So first of all, components already here. So you are using Fg, gravitational force, components of gravitational force. Which component we are using? Fg, perpendicular. As you see, when you use Newton's first law for this system, Newton's first law, let's see what's going on. F net equals, F net perpendicular, let's say, equals 0. And then you can write F normal minus Fg perpendicular equals 0. So your normal force, Fn or n, you can say it's fine. Normal force is equal to Fg perpendicular. So Fg perpendicular, how we are getting Fg perpendicular? M times G times cos alpha. All right. For perpendicular, this is our F normal, mg cos alpha. For this system, mg plus fg, F applied, sorry, now F applied sine, and then mg minus F applied sine. This is our normal force. All normal forces for all cases. Till case 5, we have done. So next step, what we are going to do, if you have, maybe you are going to have just apply force here, this is long process, but for now it's fine. You can study, so quick revision, but unfortunately we cannot cover everything in one period. I'm trying to remind you what we know, what we have to know for each topic. All right, so first of all, we said we calculate normal force. Now we are going to calculate friction force for each. Okay, friction force for first one, case 1. What we know for friction force? Friction force is equal to coefficient number times normal force. So our friction force equals coefficient times m times g. When you get normal force, easy to calculate friction force. Sometimes they can give you coefficient number, ask you friction force, or they can give you friction force and ask you coefficient number. So how can we calculate coefficient number if they ask? Friction force over m times g. That's it. It's easy for you. So for this one, what's our friction force? Friction force is equal to coefficient times m1 plus m2 times g. As you see, just writing here for normal force, let me use this side for case 3, friction force. Friction force is equal to coefficient times what we have, mg minus F apply sine alpha. Okay, so this is my friction force for this system. And then when you come this side, friction force times by coefficient number times normal force. So let's use, and let's write here. What we have, my friction force is equal to coefficient number times normal force. So you can write coefficient number times m times g plus now F applied times sine alpha. I hope everything is fine. When you come to case 5, let's write friction force now, coefficient number times m times g times cos alpha. All right, this is our first thing we have to know, calculating normal force for different cases. Normal force, we are using other forces, maybe gravitational force, maybe applied force, maybe both of them, depends on case. And then when you get normal force, easy to calculate friction force. So I think we have done cases for calculating the normal force and friction force. Coefficient number is times normal force. All right, let's continue with next one. Let's see what we have now. We can clear all and continue. Next slide, we have free body diagram and force diagram. So now We must just work on free body diagram and force diagram for different objects, different positions. For mechanics, what else they can ask you? Okay, let's continue. First of all, calculating friction force. I hope it's clear. Calculating normal force is done. And all definitions, you know. And what is next? Drawing force diagram or free body diagram, or maybe both of them. We don't know which one is coming, but we should know how can we draw force diagram and free body diagram. First of all, on the system, you can show all forces. It's up to you which method you are using is fine. Firstly, okay, first of all, what force we have? We have tension force this way, right? And then we have what direction we should know. M1 is sliding up. Okay, direction of motion is important. Why? Because friction force depends on direction of motion. So we have this way, friction force, and normal force always perpendicular to surface, remember that? And gravitational force always going down. So this is my FG. So you can draw force diagram by showing all forces. This is M1, this is M2, because M2 we have tension force this way, tension force always pulling, and gravitational force from center of object. Just remember that, please. If you are drawing force diagram, starting point for gravitational force, and then a friction force parallel to surface. Remember that. As you see, it's here, not on just somewhere else. All right. So that's important point. Normal force starting from surface and perpendicular to surface. So if you do this, are you getting full mark? No. Why? Because we should write all names of the forces. F, tension, or you can say tension, just T is fine. You can write any of this. What we have, tension force. Tension force, we should say. And what else we have? Fn, or just N, normal force. We should write all names. We must label them. Otherwise, you are losing your 1 mark. So F, or just small f. What we have? Friction force. Friction force, I'm writing names, all forces. What else we have? Fg. Fg, or you can show with another symbol, gravitational force. Gravitational force is next one. Please try to remember, just try to write all names, all symbols. Otherwise, you are losing your mark. Please remember that. So force diagram for both objects, I'm trying to show all different systems, but of course you have more. You can go to your, your past paper questions, and you can see other types of questions, but we are trying to have revision with you, quick revision, all right? So this is my force diagram. Let's see this side force diagram. M1 is here, all forces. This way we have tension force, and then now they said M1 is moving to the right. So direction of motion this way. Also friction force to the left. So we must just show all forces on the system first. As you see, we have Fg going down and normal force going up, and then you can draw your force diagram for M2. I think you are okay with force diagram. Only starting point for forces and gravitational force from center, friction force parallel to surface, just down here, and then tension force, direction is important, always pulling, we said, tension force for M2 is pulling, and then gravitational force always down, but start from center. Normal force, perpendicular surface. All right, it is all force diagrams. And then free body diagram. Free body diagram, you can just show like this, or you can just show with dots. It's much better, I think. You are showing all forces, tension force, and we have what we have, friction force. You can show with small f, and gravitational force is going down, Fg or W, you can use one of these is fine, and perpendicular to surface, normal force. After that, of course, we are writing all names. Force diagram, free body diagram, done. Let's continue with next one. Let's see what else we have. Okay, Newton's first law, second law, third law. You are using Newton's first law, second law, third law to calculate your acceleration or tension force. So Newton's first law for normal force. Do you remember that? We have done for normal force. Now for horizontal one, we can use Newton's first law also. Newton's first law, or in our definition also, we just give Newton's first law is here. F net equals 0. Newton's second law, acceleration equals F net over m. So of course we should know these definitions. And F net equals m times a. F net with Newton, and then mass with kg. Acceleration with meter per second square. So, and then another one for it's coming from momentum for Newton's second law. Net force is equal to the rate of change in momentum. What was the rate of change in momentum? It was force, net force, right? Net force is equal to the rate of change in momentum. That's another definition for Newton's second law. So these all definitions, all formula here. Let's continue. Newton's third law. Newton's third law, another definition we should know when a body, just so you know all details, you please study, please try to memorize, nothing to do, sorry about that. So action and reaction force, we say action and reaction force, another one. And you can use this one to get delta, maybe velocity, maybe you can use another one, you know, it's coming to motion now, so get delta x maybe. So Newton's second law contains Newton's first law, because if acceleration is 0, F net equals m times a, right? If a is 0, so F net equals 0. So automatically going to Newton's first law. All right. So, and lift problems we have. Lift problems we have, guys. For lift problems, we are using on this, you are in on just inside the lift, and then you have scale here. You measure your weight. So if you are just going without acceleration with constant velocity, if they said constant velocity or just going without acceleration, you have normal weight, your weight formula, you know, m times g. But if accelerating up, your weight is equal to m times g plus ma. All right, so you see more weight. If you want to be happy, accelerate down, because you are going to see less weight. So m times g minus m times a. And then you are happy because you think you are losing your weight, but that scale is lying you. So it's not true. So mg minus ma. But if you are moving with gravitational force, it means you are falling down, you are going to die. So weight equals m times g minus m times g, and then your weight will be 0. So this is another case. Lift problems like this, in multiple choice questions or maybe short question, they can ask you which position do you feel more weight, or what's your weight is less than normal weight or more than normal weight. If you have more than normal weight, it means you are accelerating up. If you have same with normal weight on scale, if you see same weight, it means you are going with constant velocity. But if you see less weight than normal weight, it means you are accelerating down. If you see 0, it means you are dying, that something is wrong. All right, so please remember all definitions, all formula, we are using weight equals mg plus ma or minus ma, or directly you can say m times a, but acceleration is negative. You can use another way, it's fine. So this is lift problems we have done. And then Newton's law of universal gravitation. So that's another one, universal gravitation. So every object in the universe attracts each other. So we using this formula, force equal to g m1 times m2. Gravitational force, and then mass on first object, mass on second object. So, but what kind of questions come? Mostly coming like this. If you make double mass, just both masses double, you know, just force increase by 4. Because if you put 2m for each, 2m1, 2m2, what's going on? Let's see. This is your normal force, but if you say g times 2m1 times 2m2 over r squared without changing distance. So 2 times 2, 4. Take from just 4, g times m1 times m2 over r squared. So we know all of them, f, so 4f. just increase by 4. Both mass half, what's going to happen? So 1 over 4, because 1 over 2, 1 over 2, 1 over 4. But distance increased by 4, what's going to happen? So decrease, your force decrease by 4. Do you remember we said just make 1 over 2 and 1 over 2, and then square, just making 1 over 2 square is equal to 1 over 4. But it's coming from this formula. How it's coming, just let's try to explain. If you make double distance, what's going to happen? You are writing 2r. Okay, let's write here. F is equal to F2, we can say. F2 is equal to G times M1 times M2 without changing mass, all right? So 2r square. So what's going to happen? G times M1 times M2 over 4r square. So you can take it, just say 1 over 4 front, 1 over 4 G times M1 times M2 over r square. So 1 over 4. If you just make double distance. If you decrease distance by 3, increase. So if you just increase distance, your force decreasing. Decreasing distance, force increasing. Just remember, as you see, increase, decrease. If decreasing, increasing. Just remember that, but take square, all right? So 2 square is 4, 3 square is 9. You can use that way, easy way, or you can calculate this, up to you. This is Newton's law of universal gravitation. Let's continue with next one. Let's see anything else we have. Yes, from now going to questions. Okay, for Newton's law, number 1, all definitions. Newton's first law, second law, third law, just all types of forces we should know. And then calculating normal force, calculating friction force, calculating tension force, and by using Newton's first, second, third law, and calculating acceleration. Okay, how we are calculating normal force? We did show m times g, or m times g times cos alpha for the inclined system. You remember, right? So all different cases. But when you come to friction force, coefficient number times normal force. But to calculate tension force and acceleration force, you are using Newton's second law. F net is equal to m times a. You can go to your past paper questions. Please try to get all these kind of questions, friction force. So sometimes they can just combine with motion. They can ask you delta x also. Just moving, object is moving up, or using this way, delta x. What are you going to do that time? You are getting acceleration from Newton's second law, and then using equation of motion. For example, v final is equal to v initial plus a times delta t, or delta x is equal to v initial times delta t, plus 1 over 2 times a times delta t squared. So all equation of motion you can use and calculate delta x. So we have this kind of things in our mechanics, and then you have multiple choice questions, of course. One multiple choice question, 1 or 2 just multiple choice questions coming. So it is just example for you. Please go to past papers, multiple choice questions, try to get different multiple choice questions. Because of time, I cannot give all examples, but if you can go to our other videos to get more examples, or directly past paper questions, up to you. So now they're asking you, which one of the following forces is defined by the statement above? So perpendicular force, yes, by a surface on object in contact with the surface. So answer is normal force, of course, because we know normal force perpendicular to surface. So if you know definitions, easy to calculate this kind of questions. All right, please try to remember Newton's first law, second law, third law, and then you can get. Let's give one more example, and then we have done for today. So this question from different past paper, from past paper questions. First of all, let's see our question. 20 kg object you have, yes, inclined system with 30 degrees, and then constant force, apply force is just acting here. We can say apply force. Let's say apply force, all right. And then, okay, constant velocity, it means acceleration is 0. So it's easy one, huh? Sometimes acceleration we have, sometimes we don't have. And friction force also given, friction force 18 newtons, all right. As you see, in long questions, they are asking you one definition. Now they ask you Newton's first law. Next time, maybe Newton's second law, third law, universal gravitation, or acceleration. You know, please try to memorize all definitions and draw a free body diagram, labeled free body diagram. So it means you should show all names. All right, free body diagram. Maybe next time they are asking you force diagram. When you check past paper, please try to write option. Okay, now they're asking me free body diagram. It means next time they can ask force diagram. But there is no another option. All right. So if you study with past paper like this, so 100% you can get good mark. Calculate magnitude of force, apply force, we are gonna calculate. And then they said when you remove force, apply force, and then X and Y surface, okay. Frictional force still acting, 18 newtons, all right. Still moving up Y to X, all right. Write down the net force acting, okay. Calculate distance. As you see, yeah, that's the distance. Now they're asking you distance. But next time they can ask you, maybe friction force is not coefficient of friction number they can ask you. So how we can get friction number over normal force? So you must get normal force. How can we get normal force for this system? Do you remember? M times G times cos alpha. Now alpha is 30 degrees. So you can use this one, coefficient number you can calculate, or coefficient number is given, let's say 0.5, and then asking you friction force. You know, I'm trying to give all different options. And what else they can ask? Coefficient number times normal force. How we know normal force? From our case 5, right? M times G times cos 30. All right. So what else they can ask? Let's say cos 30 here. And then maybe they said constant velocity. Now next time with acceleration. So they can ask you acceleration. So how we are going to calculate acceleration? Newton's second law we are using, m times a. So a is equal to force over mass. You can use this after, or if you have two objects, you can use just tension force maybe next time they're asking. So different questions waiting for you. Please go to past paper questions and then try to get all types of questions. All right. So let's continue with this question. Let's see what they ask. Newton's first law. Okay, Newton's first law definition is here. So you just get it from your, all definition list we shared on our first slide. So Newton's first law, please study Newton's first, second, third, all Newton's laws. So let's continue with next question, 2.2 now. As we say, asking you free body diagram. Free body diagram, how we are drawing what we said. First of all, on the system, please draw all forces. We have apply force here. And then object is going up or down. Let's see first, direction of diagram moves up. Okay, direction of motion is very important because to get friction force, object is moving this way with constant velocity v, and friction force on the surface is here. And then we have gravitational force, of course, normal force. So these are free body diagram, but what we said, they can ask you force diagram. Maybe if they are asking you force diagram, what you are gonna do, you're just taking out that box, and on that box, you are showing all forces. So weight or gravitational force and friction force on the surface, friction force is here. And then we have apply force. Let's say if apply here, apply force. And what else we have? Normal force perpendicular to surface. As you see, just using box here, we can say, but remember friction force here, and then gravitational force start from center and normal force perpendicular to surface. Of course, we must label them. All right, so this is our free body diagram and force diagram here. Just check all of them. Two types of diagram we have. On your exam, maybe one of these coming. And then calculate net force. Okay, calculate, so not net force, apply force. Okay, we are looking for apply force. Let's say another question. What else we said? Maybe tension, maybe acceleration. Next time they can ask, please be ready for all kind of questions. Okay, let's continue with next one. We are looking for applied force. We are using Newton's second law and writing formula. One of these is fine. They said you can use any formula. And friction force. Okay, how we are getting this equation? It looks scary, right? So let's just show on free body diagram will help you, of course. We have friction force this way. We have applied force this way. So applied force minus friction force and minus V, it's a W or FG, you can say FG parallel. So F applied minus friction force minus FG parallel, or F applied minus F friction plus. So in brackets, when you open brackets, you can write them all minus. So these are Newton's second law. So to get FG parallel, we are using M times G times sine 30. Okay, for parallel, I'm using this equation, M times G times sine 30 degrees, because our angle is 30. All right, but just in case, just let's see, if friction force is not given, and they are giving you mass, and then let's say coefficient number 0.2, for example. So how you are going to do that time? You need your just W perpendicular, because to get normal force, you need, it is perpendicular, I couldn't draw. So normal, so you are getting friction force like this, coefficient number times normal force is equal to FG perpendicular. So you can write M times G times cos alpha. I hope it is clear. Or let's say coefficient number is not given, but friction force is given here, asking you coefficient number, how you are going to do friction force over M times G times cos alpha. So we can just give all kind of questions, all different questions, but all coming from forces. Newton's laws, all coming from forces. Just take, if you have two objects, it's fine, still same stuff, all right. Separate M1 and M2, and then just get different calculations. If you need, you can combine to get tension and acceleration force. You just combine and get tension or acceleration, maybe both of them. All right, so you are using that. Or second option we have to calculate our applied force. You can use work energy theorem. As you see, work net is equal to delta EK. So using this formula, it's also possible. F applied times delta X times cos 0. Why cos 0? Do you remember work energy topic? Because parallel to direction of motion. Object is going up. If applied this way, same direction. Because of that, cos 0. For friction, we are using cos 180. Why? Because opposite direction of motion. And then for weight parallel, just weight is parallel here. So we are using that delta X times cos 1. Oh, just another use. Okay, just that one. Leave it for now. Not urgent. If you use F apply is much better. Straight using F weight, and then they said 120. For now, we can leave it this one. And then let's continue with 2.4. 2.4, they said, write down the net force acting on the block. If you remove applied force, what's going to happen? And then you are coming to position X and Y. For this position, what you have now, if object still going up, but there's no applied force, you have friction force here, and then you have weight parallel. So, and then you can say 116, still same force acting, because just moving with, let's see, just continues to move up, surface come to rest at point Y. So friction force 18 newtons. Friction force 18 newtons, still same. And a direction of forces, because we calculate already weight, just gravitational force parallel and friction force total. We calculated 116 newtons in question 2.3. It's still same. F plus F FG parallel is equal to 118 and down. So as you see, direction is still same, but object is going up but slowing down now because of friction force. Because of it, there's no applied force, slowing down and stop. All right, so we have done question 2.4, And next one, last one for today, 2.5. 2.5 asking you calculate the distance between x and y using Newton's second law to get acceleration. What we said, they can ask you friction force, normal force first, normal force, friction force, acceleration, or tension force, or displacement they can ask. So what we are going to do, what we said, we are using Newton's second law to get what we need. For now, we need acceleration. So you are getting acceleration first. When you get acceleration, you can use Newton's equation of motion to calculate delta x, or V final, or V initial is given. So they can ask you different questions. So we have done our revision. I said quick revision, but I don't know if it's quick or not. So we try to cover most of stuff, but not everything. Please go to past papers and then try to get some different questions to make sure you are getting full mark, good mark. Have a nice day, everyone. See you next lesson. Hi, everyone. Welcome back. Grade 12 physics. Today's topic is momentum and impulse. Quick revision for momentum and impulse. So let's continue. Let's start. As you know, we are starting with our all definitions. We have momentum, the product of an object's mass and its velocity. It's giving you formula also, P equals m times v. We are going to see now. Impulse, the product of the net force acting on an object and the time the net force acts on the object. Newton's second law in terms of momentum. Newton's second law we did study in mechanics topic, but now Newton's second law in terms of momentum. The net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. And isolated system, one on which the net external force acting on the system is zero. And conservation of linear momentum is another definition. The total linear momentum of an isolated system remains constant. And elastic, inelastic collision. Elastic collision means collision in which both the total linear momentum and total kinetic energy remain the same. Inelastic collision in which the total linear momentum is conserved, but total kinetic energy is not conserved. So total kinetic energy different. All right. So all definitions here about momentum and impulse. Let's continue. So momentum. Formula for momentum, symbol is P, and we are using formula m times v. Momentum equals mass times velocity. You remember definition, what they said? Linear momentum of a particle or object is a vector quantity. Definition, where is it? Symbols. Okay, product of mass and velocity. So we can write this formula from that definition. And then example is here, if mass is 1000 kg for object and 8 meters per second for velocity, and then asking you momentum of the object, momentum of the car, P equals m times v, 1000 times 8, and 1000 kilometer times meter, kg times meter per second. Direction east. So momentum is a vector quantity. Because of that, it has direction. All right, so linear momentum and momentum formula, m times v. What is m? Mass with kg, and v, velocity with meter per second. So, and Newton's second law for momentum, Newton's second law, what we know, F net is equal to m times a. And then we can write for acceleration delta v over delta t from our motions equation, m times delta v over delta t, m times delta v giving you delta p. Delta p is impulse. So impulse over time is giving you F net. So the net or resultant force acting on an object is equal to the rate of change in momentum in the direction of resultant net force. So this coming from Newton's second law, coming from mechanics. And then change in momentum. So it is impulse. Impulse is change in momentum, delta P. P final minus P initial. What is P final? Mass times V final minus mass times V initial. And then you can write impulse is also a vector quantity, all right? Its unit is n times s, Newton times second, because F times delta t is giving you impulse, or kg times meter per second. So m times delta v also giving you impulse. Sometimes in past paper questions you see, in our examples you are going to see, they are giving you mass, V initial, V final, and asking you F net. So how can we calculate F net? F net is equal to m times delta V over delta t. What we said, when you check past papers, please try to get all kinds of questions. Try to get different questions, how they can ask you, how they can change the question. So, or they can give you F net and asking you delta t. So delta t, so m times delta V over F net, sorry. F net you can write, you can calculate your time. So, okay, we'll see that kind of questions now. So impulse, momentum, all definitions, I hope we are okay now. Let's continue with next one, safety rules, okay? Safety rules coming from impulse. So firstly, airbag, okay, just by using all equations, when the contact time increase, yes, when the contact time increase, you are in safe. Okay, increase in contact time, you are in safe, but contact time is less, because contact time is less, getting more force, because F net is equal to delta P over delta T, change in momentum over time. If you have more time, F net getting less. So you are going to be in safe. So let's see, seat belt is doing that job. So getting just increasing time, and then crumpling zone also increasing contact time, and bending knees also helping you just get more time, just contact time. All of them helping you to get less force. More touching, more contact time, getting less force. Just like, just bouncing, when you go bounce and jumping. So first the contact time slowly is going down and then increase. Just think about that. Someone is coming to, strong, just straight floor, just hard one. So of course it is dangerous. So it's coming to bouncing, so maybe for meters, just it's coming down, it's safe. So contact time must increase. To increase that, you can use different stuff, airbags, seat belt, and crumpling zone, all other stuff. Okay, let's see what else we have. Impulse and change in momentum graph. We have force and delta T graph. Impulse is equal to F times delta T is giving you delta P. So this area on F and delta T, this all area giving you impulse. For example, between 0 and 2, 2 times 6, 12. Delta P is 12. Impulse is 12. Or from 2 to 4, 2 times also 12, 2 times 6. But when you come to 4 to 8, so you have triangle here now. How you are going to calculate that area? So we have 4 here total and 6 up. So 4 times, sorry, this is 6. 4 times 6 over 2, because it is triangle, you can calculate that area. 4 times 6 over 2. Also 12. Unit is kg times meter per second, or Newton times second. So 12, because 4 seconds now, 4 seconds making 12, but it was 2 seconds, but now it is, force is getting less. So area is giving you impulse, just remember that, from force and time graph. Total impulse, when total impulse is calculated, the areas of each figure will be added. So if you are looking for total impulse from 0 to 8 seconds, you must add these all 12, it was 12, right? 12 and 12, total impulse is 36. All right, you can use just your graph to get impulse. Let's clear all and doesn't want to clear, okay. Let's continue. Next one, conservation of linear momentum. The total linear momentum in our first slide also we did show. So total linear momentum of a closed or isolated system remains constant. In physics, closed isolated system is very important. So we are using this formula, conservation of momentum. So delta P before, or initial, you can say total P before and total P. Total momentum before and after, same. P1 initial plus P2 initial equals P1 final plus P2 final. So what we know about P, momentum, so we can write formula like this next step, M times, let's see, M1, first object, M1 times V1 initial plus M2 times V2 initial equals M1 times V1 final plus M2 times V2 final. So we have three different cases for conservation of momentum. First one, you have two objects, M1 and M2. It is case one. Let's say M2. They are coming to each other. It is before, let's say, before. It is case one. Okay, let's show all cases, plus minus same stuff, but you'll see now. Before, just they're coming to each other. This is my V1 initial. This is my V2 initial. And after that, for case one, after that, they collide each other and they separate from each other. And maybe they are going different direction, maybe same direction, it's fine, but they separate from each other. So this is my V1 final, M1 still here, and then M2 is here, and then V2 final. So before and after, this is case one. They collide and separate. So using this, but for this kind of questions, direction is very important. Just say, for example, east, positive, east as positive. Just say east, positive. So the initial, V1 initial is positive. For example, let's say 5 meters per second, you must use plus 5. And then, so V2 initial is negative. If it is 5 or 15, you should say minus 15. All right, please remember that. We are going to see our question just now. And then for this one, for example, V1 final is negative, V2 final is positive. Remember, choose east positive or west positive, but choose positive and negative. Final answer, when you get your answer, you said initially you said east positive, and then you are getting positive answer. It means you can say your direction east. All right, using that, this is our case one. What about case two? Case two, they are coming, just collide first. Okay, let's say before. Let's try to write nice one. Before, you have two objects. They are coming to each other. They collide, M1, M2, and V1 initial, V2 initial. And after collision, they collide and they are moving together. Okay, now let's choose this way. It's fine. V final. So for this case, M1, M2, we can say plus. So this is case one. You have different calculations for this case. You can use, okay, this formula, okay, starter, you are writing like that. You can say M1 times V1 initial plus M2 times V2 initial equals M1 times V1 initial, V1 final plus M2 times V2 final. It means same formula. All right, you are using same formula for all cases if you want. So, but we should remember V1 final and V2 final same. All right, just you must use, just you must know, you have same, you can say just V or, just make same, or other option, M1 times V1 initial plus M2 times V2 initial equals M1 plus M2 as a one object. You can just combine them, just write V. Because I know just they collide and they are moving together after collision. You can use this calculation. We have another case. Another case is case three. Case three, initially they are together. Okay, before collision, just before collision, yeah, we can say before, initially they are together, M1 and M2, let's use it. But please remember, you are choosing direction. All right, let's say east positive. East positive. And so this is before, this is after. After collision, they separate from each other. Let's choose any direction, it's fine. So M1, M2. You can use same formula, M1 times V1 initial plus M2 times V2 initial equals M1 times V1 final plus m2 times v2 final. But what we know, v1 initial, v2 initial same. You can write m1 plus m2 times v equals m1 times v1 final plus m2 times v2 final. I hope it's clear now. So all cases, 3 cases, you can use same formula, but remember, case 3, initial velocity is same, case 2, final velocity is same, and then you can combine mass, and you can get conservation of linear momentum. We are learning that. So next one, elastic and inelastic collision. In definition, we also give that. So elastic collision, it means momentum and kinetic energy conserved. So how we are calculating kinetic energy? Kinetic energy formula, momentum we know. Momentum equals m times v. Impulse also we know. Delta p is equal to m times delta v, or delta p equals f times delta t. We said we are using these 2 equations, they are together. So f times delta t equals m times delta v, and you are calculating force or delta t, or both given calculating mass. You know, different options you are going to have. But now kinetic energy. What was the formula for kinetic energy? 1/2 times m times v square. So this is kinetic energy. If you have 2 objects, or before collision, after collision, just you are calculating total kinetic energy for first position and last position. And then you are going to say elastic or inelastic collision. If initial, EK initial equals EK final, and EP initial is equal, oh sorry, what EP initial, P final. So total, let's use total, yeah, it's much, yes. Total momentum, initial total momentum, you know already, m1 times v1 initial plus, yeah, just like that. But we are going to calculate our kinetic energy for example, if you have 2 objects, m1 v1 initial and m2. Okay, let's start over, just clear everywhere. So if you have 2 objects, how we are going to calculate total kinetic energy? m1, and let's use case 1, m2, v1 initial and v2 initial. This is before collision, and after collision they separate from each other. m1, let's say before, or initial, it's fine, and after. So m1 v1 final, and you have another object this way, v2 final, m2. So what you are going to do to see it's elastic or inelastic, you must calculate EK initial. I know my formula, 1/2 times m, but now m1, and m1 initial square plus 1/2 times m2 times v2 initial square. This is my initial kinetic energy. And then you are calculating final one. EK final equals 1/2 times m1 times v1 final plus 1/2 times m2 times v2 final square. So this is our answer. And then you are going to see if they are equal, you say elastic. If they are different, inelastic. And then maybe they can ask you delta EK, change in kinetic energy. What you are going to do? You calculate separately, you can do that. EK final minus EK initial. I hope everything is fine, everything is good. So this is our kinetic energy. So kinetic energy is giving you, change in kinetic energy is giving you elastic or inelastic. Change in kinetic energy maybe, if they are equal, of course, change in kinetic energy will be 0. So it is elastic collision. But if you get something else, not 0, it is inelastic collision. Anything else? Let's see. No, done. All right. So what we have learned, just go back quickly, start over. Quickly, let's remind everything. Momentum and impulse. We start with definitions. Quick revision. Momentum, impulse, Newton's second law in terms of momentum, isolated system, conservation of linear momentum, elastic and inelastic collision. And momentum equals mass times velocity. Newton's second law, m times a, m times delta v. So delta p over delta t is giving you net force. And change in momentum is giving you impulse. F net times delta t equals m times delta v. And safety rules, trying to get more just contact time. And graph, velocity time, what's it? Force and delta t graph is giving you impulse. And conservation of linear momentum before and after collision, you have total momentum same. If your total momentum and kinetic energy same, elastic and inelastic collision. So quick revision, we said it is quick, right? So now multiple choice question, one multiple choice question for you, just to see, but please go to other past paper questions. Please get more questions and more practice questions, all right? So two balls of mass m and 2m dropped from same height. Okay, let's try, let's draw and let's try to understand. We have object m and we have another object with 2m. Let's draw a bigger one. You have 2m, all right? So when the ball strikes the ground, which one of the following physical quantity will be same? Okay, weight. Let's check. What was the formula for weight? For this kind of questions, you must go to formula box and try. So m times g. As you see, weight depends on mass. For first one, weight, okay, let's calculate weight for first one is equal to m times g. And second one, v2 is equal to 2m times g. As you see, they are not equal. And velocity. Velocity start from 0 and then velocity, what's going on? Increasing. But velocity formula, velocity just only depends on initial velocity. They said, okay, drop. Okay, V initial equals for both, V initial equals 0 and V initial equals 0. What was the formula for velocity for projectile motion? Just remember, sorry, V final. V final equals V initial plus A times delta t. As you see, there is no mass here for velocity, final velocity. Both of them start with 0. Acceleration is 9.8. Time is different, it's the same. So velocity will be same for both. Momentum. What was the momentum formula? Momentum formula is m times v. So P1 equals m times v. P2 is equal to 2m times v. So they are different. And kinetic energy, EK1 equals 1 over 2 times m times v square. So what we have, as you see, m. And then v final is same, but let's say v final, because they said before touching ground, yeah, almost just touch ground. So next one, 1 over 2 times 2m times v final square. Okay, v final same, but m and 2m different. Kinetic energy also different. If they ask you potential energy, what's going to happen? Potential energy, same or not? Potential energy also different because EP1 is equal to m times g times h, and EP2 equals 2m times g times h. I hope everything is fine. So they can add, they can change question. Now they said different mass. Maybe next time different starting velocity. You know, just they change question. But you must go to formula box and get formula and try for each. All right. So let's continue with next one. Today, one multiple choice question and one long question for you. So as you see in long question, they're asking you one definition. Now they're asking you elastic collision. Maybe next time asking you momentum, maybe impulse, maybe conservation of momentum. So you know our list, right? Maybe kinetic energy they can ask you. So please just study all definitions, whatever we have. Kinetic energy is fine, just it's here already formula. Okay, so you have two objects. Initial x, initial velocity is 2 meters per second east. Y, we don't know initial velocity for y. For final, after collision, x 0, stop moving, and y is going to east with 30 joules or joules. Just be careful about this one. As you see, they didn't give you velocity, but they give you kinetic energy. So if you know kinetic, it's easy to get velocity, right? You can do that because E kinetic equals, before I start answering question, I want to get final velocity because it's much easier for you. So E kinetic is 36, E kinetic energy, 36, 1 over 2 times mass, is it given? So x 10 kg, y 2 kg, okay, times 2. And velocity we don't know. So velocity giving you 6. Okay, this way, 6 meter per second. Okay, I know that from question. All right, we just meter per second. We calculate. So elastic collision definition is here. Collision in which both the total momentum and total kinetic energy are conserved. So you know that. And velocity Vy. So we are going to calculate Vy. How we are going to calculate? Using conservation of momentum. Total P initial equals total P final. I'm using that formula. M1 times V1 initial plus M2 times, you can write X, Y, it's up to you, it's fine. And M2 times M2 initial. And then M1 times V1 final plus M2 times V2 final. They didn't tell us use conservation momentum. Maybe you can use other options. You're going to see in memo now. It's up to you which one is easy for you. You can choose other options. Let's see. As you see, using conservation of kinetic energy, using that. And then conservation of energy, they are using conservation of kinetic energy, or using kinetic, okay, getting kinetic energy first, what we did before, kinetic energy first, and then, okay, kinetic energy as you see 6 meters per second, and then using conservation of momentum. As you see, M1 times V1 initial, M2 times V2 initial, M1 times V1 final, M2 times V2 final. So you are just writing all givens and calculating for, but remember, you must choose when you start, except just which side is positive. So now let's see which one they are choosing. They said east positive now, because they, as you see, positive for 2, east positive. Just say east as positive. If east is positive, you must use 10 times 2, because I know mx is 10, vx initial is 2, and then my is 2, but my initial, I don't know. Mx 10, but mx final is 0, just if you are writing 0, and my is 2, and vy final is 6, positive 6, because it's going to east. When you calculate it, you are getting negative. You are getting negative 4 meters per second. So this one is giving you direction. Please don't leave it like that, all right? If you leave it like that, you are losing your mark. Remember that. So this negative is giving you direction. So it is west. Why west? Because we said east positive, or it is given here. You can straight use this. East positive, west negative. And another option is here. You can just carry on. We have, I think this question 6, 7 options, but I am giving you only first 2 is fine. And then let's continue, guys. Let's see what else we have. I think impulse questions coming, so more options here for 4.3 now. So now we are calculating magnitude of net force on ball X, net force on X. Okay, using impulse question, if net times delta P is equal to delta P, I know delta P is equal to M times delta V. What is delta V? V final minus V initial. You can use any formula and get 1 mark for formula. And contact time, touching time is given 0.1. Mass is 2. Why I am using this 2? Because on ball Y. Okay, on ball Y. We are looking for from X to Y. So on Y, I'm calculating and then getting 200 newtons. As you see, it is positive. So from X to Y, as you see, force to just going east to the right. All right, positive. But if you say for X, now you are calculating which force? F, Y, X. From Y to X. From Y to X, this F, as you see, west. So getting negative. But you should just say, calculate magnitude. So they're asking magnitude, so if you get 200 newtons, it's fine. But maybe they said with direction, you must say which one on the ball Y. So it's going east. On the X, X, using impulse formula. All right, F net times delta T equals delta P. You can use other options, equation of motion. It's up to you. You can use. Today we have done. Please go to other past paper questions and try. You can try our videos about the momentum and impulse. We have other videos. When you have time, you can go and you can Watch those videos also. Good luck. Have a nice day. See you next lesson. Hi everyone, let's continue with photoelectric effect. Today, quick revision with photoelectric effect with some questions. So, photoelectric effect, everything starting with energy levels. Electrons moving from one energy level to another one. As you see, we have two different types of process. First one, electron is moving from lower level to higher level and taking all energy from system. But second one, electrons moving from higher level of energy, higher level to lower level. And this time, electrons just making energy, release energy. So let's continue. So in this topic, we have these definitions: photoelectric effect, threshold frequency, threshold wavelength, work function, and others. So these definitions, everything we should know, nothing to do. Please try to memorize all of them. So photoelectric effect, this is process, emission or absorption. So threshold frequency, minimum frequency of light needed to go up level. So this is our threshold frequency. We'll give more details in other slides. And wavelength, maximum. Please try to see these differences. Frequency, minimum frequency, but wavelength, maximum wavelength. Wavelength must be shorter than threshold. Normal photon wavelength must be shorter than threshold frequency. Because of that, threshold frequency must be maximum wavelength. All right, these definitions, please try to remember. And let's continue. Yes, we said everything starting with energy levels. So first one, absorption, electrons going up from lower level to higher level. So an energy coming with photon or electrical energy. So just energy is coming with HF. What is H? Planck's constant. It is constant number. H equals 6,63 times 10 to the power of -34. It is constant number. With constant numbers, everything I will show you all in one, everything I will show. And then we have energy and we have metal surface. Okay, we have two different things. First one, coming with energy, we have energy, and this one has energy, this one has frequency and wavelength. And then when you come this side, electron has energy. Just to go up, we have minimum energy. That one is work function, V0. We are calling work function. Also, they can ask during exam. So first one, this is minimum energy to go up. In all definition list, you see work function. Work function is minimum energy to take electrons higher level, from lower level to higher level. So work function equals minimum energy to take electrons from lower to higher. And formula for energy of photon formula is E equals H times F with frequency. This is F, frequency of photon. Okay, we should separate, all right, energy of photon and energy of electron, so minimum energy, work function. When you want to write formula for work function equals H, still I'm using that Planck's constant here, H times F0. This is minimum frequency. Remember in that list, definition list, minimum frequency, HF0. So we are trying to take this electron from lower level to higher level. To go up, it needs energy. Okay, taking energy from photon. So minimum is work function, and this is energy. This E must be higher than work function. All right. So remember, let's write, we're going to make list here. E must be higher than work function, higher than minimum energy. Extra energy will change to kinetic energy. It is coming. We are going to explain that. So E must be more than work function. I hope it is clear now. And then what about this frequency? Frequency also must be higher than threshold frequency. These two done. We should know these two because they can ask you some questions. They can ask you which one, what we need for energy and frequency. Energy and frequency. Energy must be higher than work function, higher than minimum energy. And the frequency must be higher than threshold frequency. And then wavelength is coming. So energy is fine. Work function, you are comparing with that. Frequency with threshold frequency. Energy for photon, frequency for photon, for light, but work function for electron on surface of metal, surface just for electron, let's say, it's okay. And the work function is work function. And then threshold frequency, it is minimum frequency for electron. I hope you're all clear. From now, wavelength. Wavelength must be shorter than threshold wavelength. Let's write formula, energy formula with wavelength, hc. What is c? Speed of light. Speed of light, 3 times 10 to the power of 8. Let's use this side. C equals 3 times 10 to the power of 8 meter per second. So hc over lambda is giving you energy of photon. This lambda here, this is wavelength of photon. So this wavelength must be, maybe we can show here, it's supposed to be shorter than minimum wavelength. So work function formula also we can write with wavelength hc over wavelength 0. Yes, remember that. If you are writing formula for work function, wavelength 0, F0 we are using, but formula, energy formula for photon, we are using lambda without 0, frequency, so we also without 0. And remember, wavelength of photon must be shorter than wavelength of electron. Okay, why? Because if you want to take, okay, let's try here. This is different color. So wavelength, if it is short, it's fine. It can go and it is fit this side. But just think about that. If you have big one like this, so it will not go inside because it is too long, you know, just to hide. So it's supposed to be short. It's supposed to be small. Oops, sorry. So remember, we are drawing this one. Okay. So we have photon, light is coming to electron, electron getting that energy go up. So we have this formula for energy. And from now, let's talk about kinetic energy. Okay, let's clear all now. So if you have energy more than work function, what's going to happen? Electron will start. Electron will move. Electron starts moving. So it's going to go up, will move. So we can say energy equals work function plus kinetic energy. All energy, extra energy will change to kinetic energy. So from this formula, we can write kinetic energy, maximum kinetic energy equals energy minus work function. So what was this energy? Energy of photon. And this one is a minimum energy to take electrons up level. I hope it is clear. So you are using this one to get maximum energy. And then they can ask you another question. Calculate velocity of electron. What we can do, you are going to calculate kinetic energy from this formula. And then another formula, you know, kinetic energy formula is equal to maximum equals 1 over 2 times m times v squared. So using this one, This is constant number, mass of electron, and you are getting Vmax from this formula. You can use two steps, energy of photon minus work function, getting Emax, E kinetic energy max, and then kinetic energy, using this kinetic energy to calculate Vmax. All right, this kind of questions they can ask you. We have absorption and emission here. So emission, it means opposite. Now from higher level to lower level. All right, electrons moving, but this time they don't need energy. They are gonna give off energy. Those extra energies, they are producing energy. So energy release, and this is same formula, HF, but we are not busy with work function or F0 wavelength here. Only those energy release, but kinetic energy just going also off. So finally coming to this level, change to work function now. This energy release from this energy level emission here. And then, as you see, showing also absorption, electrons going to higher level, emission, electrons going to lower level, from higher to lower. And, okay, anything else to remind here? Nothing else. But this one, not 1 eV. Sometimes energy is given with EV. EV is 1.6 times 10 to the power of negative 19 joules. If you need to convert, for example, some energy of photon given with 2 eV. So you are going to write 2 times 1.6 times 10 to the power of negative 19 joules. And you will say 3.2 times 10 to the power of minus 19 joules. Just like that, you should convert it. All right. Remember that. And I think everything is clear so far. Let's continue with next one. Let's see what else we have. Absorption is fine. Work function, threshold frequency, threshold wavelength, done. Let's continue with next one. Now, talk about colors. So lowest energy level, red color, highest blue color. We see these colors because, and then one more thing we should explain. Let's go back. So to release energy, we are having different colors. First one, absorption. When it is taking energy from system, so what's going on? All temperature of system decreasing. Okay, getting cold and then getting dark because taking all energy from system. Electrons taking all energy from system. Remember that. And then when energy is going down, electrons going down from higher level to lower level, and then produce light. So now it is coming with different colors, and then temperature increasing now, so getting these colors. All right, so from lowest level, red color, highest one is blue color. Just remember these colors also. And other formula, you remember from our topic, we have V equals wavelength times frequency. I'm changing this V by speed of light. C equals wavelength times frequency. And then do you remember energy is equal to HF? So for F, I'm writing C over wavelength. Because of that, energy formula, two formula we can write. What is that? What we have, HF or HCF. But same formula for work function. How can I write? Work function is equal to H times F, 0. Remember that? And then work function is equal to H times C over wavelength, 0. This formula in formula box you will have. So we have done. And then what else we have? We have another unit here with A. 1A equals, remember EV with joules. This one is special for length. So 1A equals 10 to the power of negative 10 meters. Sometimes wavelength is given with this unit. Remember that wavelength is given with that unit. And we have some other units. I hope you remember those units because okay, this one not just for wavelength. For example, 1 millimeter is equal to 10 to the power of negative 3 meters. These units we should remember. Or they can give you 1 milliampere, 10 to the power of negative 3A. Or 1 millicoulomb, 10 to the power of negative 3 coulombs. You know that, right? So milli, 10 to the power of negative 3. And then same stuff with micro. Next one is micro. Micrometer equals 10 to the power of negative 6 meters. 1 microcoulomb, 10 to the power of negative 6 coulombs, and then nanocoulombs, NC or NM, it's fine. So 10 to the power of negative 9. Maybe picocoulombs they can ask, 1 PM or PC, 10 to the power of negative 12 coulombs. All right, so remember we said extra energy is changed to kinetic energy. So E equals work function plus kinetic energy. You know that. So E is hc over lambda, you can write. Hc over lambda equals Ek plus work function. So just differences is giving you energy minus work function is giving you kinetic energy. Kinetic energy, other formula, we done already that, 1 over 2 times m times v squared. So you can calculate velocity by using these two formulas. All right, let's continue with next one. I hope everything is clear. So quick revision we said, because of that, quickly let's explain everything and then let's ask you some questions. Let's try. It is formula box from past papers, from last year's past paper. So this formula is given. This one is given, but they didn't give you C equals F times wavelength, but we can write that formula, just change by speed of light. Period equals 1 over F. And this is from Doppler effect because they put them all together. E equals HF is equal to HC over lambda. And work energy formula here, energy work function kinetic energy. And then kinetic energy formula also given. All right, all from formula box. When you see, remember, m is constant, mass of acceleration. Sorry, mass of electrons. Mass of acceleration. Okay, yeah, it's here. It's another table. Which one we are going to use for this topic? We are using H, Planck's constant. We didn't write unit last time, just I didn't remember that. But unit is joule times second. And then next one, mass of electron we are using. It is constant number here. And C, speed of light, we are using. Anything else? K for electricity. So charge of electron maybe we can use, if they have, because today's example we can use charge of electron. All right, so this is Planck's, this is a photoelectric effect, Planck's constant, everything, and then we can go to questions. We have two different processes. Now, let's see this question, multiple choice question. Light, white light is pass a cold gas, okay. We have spectrum on the screen, all right. Which one of the following correctly described energy transition of the atom? Type of line spectrum. So this is our question. Please try. If we can just try first and then just remember absorption, just taking all energy and then change to cold, you know, just temperature decreasing, remember that. And then for absorption, energy just changing from lower to higher energy level. We can show answer now. Our answer is D, because cold gas is showing you temperature decreasing. If temperature decreasing, it means electrons moving from lower to higher level. When they go to higher level, they are taking all energy from system. And then process name is absorption. All right. If it is opposite, so you are going to change emission, all that. All right, let's continue with next question. Long questions coming. We separate 10.1, 10.2 from past paper question. And now light is coming, okay, on cathode. So taking electrons. And then question 10.1. In photoelectric effect, we are saying electrons just like particle. Okay, light has particles. So they are asking you nature of light. Let's continue with an answer. Nature of light. Light has a particle nature. All right, because we are, as you see, we are talking about electrons going up, coming down. So particle, we are talking about particle taking energy and changing their position. So light has a particle. This is question 10.1. 10.2, they're asking to define the term work function. So we should remember, we should know all definitions to get full mark from this question. Work function is minimum energy that can, just minimum energy to remove the electrons from lower level to higher level, or just you can use this definition, full definition, write it down from our definition list. Okay, and now calculations. So what is given? Work function is given. To answer, to get good mark, to get nice mark from this paper or any physics question, guys, please write givens with symbols. So has work function something? So first of all, write work function W0 equals 3,42 times 10 to the power of negative 19 joules. With symbol unit, write givens like this, because when you see formula box, you are going to use W0. So you write with symbol. And then what else given? Light of frequency. Light of frequency, F is given, not F0. All right. Remember, we have energy. We have photon, energy of photon or energy of light, and we have on the metal surface electrons. So work function, threshold frequency, F0. But light of frequency is F only. Okay. So F is given. F equals 5,96 times 10 to the power of 14, 8Z. On the question paper, you can just write it like this. All right, please remember, write it down first with symbols. What they ask, calculate the maximum kinetic energy. All right, if you want to try, please stop me and try first. But for practice, guys, we can go to other video lessons, other questions, because we are answering question and answer, question and answer past paper questions. But now quick revision, because of that, we should just carry on. So calculating maximum kinetic energy. How can we calculate? Please stop video and take your time. Please try. You remember from formula box, you can get formula, all formula. And please try first. Let's wait a few seconds to stop video. Yes, okay. So we can carry on. What we are gonna do, guys? E equals EK plus work function, we said, right? We are looking for maximum kinetic energy. So kinetic energy equals E minus work function. Kinetic energy equals, how can I get E up if I know frequency? HF. We know H, Planck's constant, F is given. So minus work function already given. So it is easy. We can just get it. Let's show from memorandum. See, E equals work function plus E max. And then you are just, it is, yeah, you are writing all givens. But if you use that way, it's much easier. Like this, EK equals E minus work function. So H times F minus work function. Okay, you can just calculate H we know, F we know, work function we know, and then you are calculating kinetic energy, done. Maybe next time, they can give you another question. Calculate maximum velocity. How can we calculate? What you are going to do? You are going to say EK max equals 1/2 times m times v max square. So we know EK max. So you can say 5 times 3, 2 times 10 to the power of negative 20 equals 1/2 times mass. We know already 9.1, we know just constant number, and Vmax. So we know everything, only Vmax you can calculate from this equation. So they can ask you that kind of questions also. So we calculate maximum kinetic energy by using energy of photon and work function. Now we have just some different question. Now they are mixing with electric circuit. Ammeter reading this current 0,012 and calculate minimum number of photon of light. Just try from so minimum number of electrons. Yes, we said electrons will go up, will move up, but now they are asking you how many electrons will move up. So for these questions, let's show, you can try first. So, and then time is given also, that time. So we are using QIT formula. QIT. So Q equals I times delta T. You are getting charge, total charge, and number of electrons equals total charge over charge of electron, using that formula to get number of electrons. First of all, we are getting total charge by using QIT. This is just with different formula, photoelectric effect. So electrostatics for questions, electric circuit questions here. Okay, we have done QIT you are using first, and the number of electrons, N equals Q over E. As you see, they mix topics sometimes. And last question for today. And quick revision, we are going to finish. And then please answer more questions, more past paper questions. All right, maybe you can try full past paper questions with all topics, or it's just for this one, for other topics. But please answer past paper questions. So now they're asking you, intensity of incident light is now increased. So how will this change affect reading on ammeter? Asking you how affecting current. So incident light increase means, okay, let's give answer straight. Okay, so their answer is increase, current will increase. Why? More photons strike the surface of the metal per unit time at higher rates. So more photons, more electrons will come. If more electrons coming, increase currents. All right, increase current, more electrons coming. So in intensity increase, current will increase. Okay, we have done our quick revision. I hope it will help you. Please answer more questions, more practice. All right, we need practice. We need to answer more questions, and then you can get good mark. So thank you very much. We have done for today. See you next lesson. Have a nice. Hi everyone, welcome back. Now, projectile motion. Quick revision for projectile motion. Let's start. First of all, as you know, we are starting with all definitions. But we have projectile, free fall, acceleration, velocity, and displacement. Acceleration, velocity, and displacement coming from motion, you know that. But now we have projectile motion. So projectile, an object upon which the only force acting is the force of gravity. Free fall, any motion of a body where gravity is the only force acting. Acceleration, the rate of change in velocity. Velocity, the rate of change in position. And displacement, the change in position. Done. All definitions here for projectile motion. Let's continue with other things, what we have for projectile motion. First of all, we have free fall. So for projectile motion, we have some important points. Each point is important, notes coming now. But first of all, let's start with free fall. What we know about free fall, you have an object and starting with zero initial velocity. V initial equals 0. And then your acceleration is gravitational acceleration, 9.8 meter per second square. This is free fall, drop from somewhere. They said initial velocity is 0. So acceleration of a free falling object is called gravitational acceleration, and symbol is G, value is 9.8. Acceleration is constant. Acceleration is constant. When we are drawing our graph, everything you are going to see, we are using acceleration constant 9.8. Okay, what else? We have same acceleration we are using. Just remember that initial is 0. That's it for free fall. Let's continue with next one. Yes, for projectile motion, we are using this 4 different equations. As you see, first one, V final is equal to V initial plus A times delta T. V final, final velocity, initial velocity, acceleration and time without displacement. And another one without time. If you don't know time in your question, so you are using this equation, and then other equation for displacement, and last one also for displacement. But last one, if you don't know what maybe acceleration is not given, but acceleration is always 9.8. So you can use this one or another one. It's up to you which one is easy for you. So just think easy. Number one, for projectile motion, we are always busy with initial position and final position. 2 points. All right. We are busy with 2 points for all calculations. First of all, just check what is my V initial and then what's my V final. And do we know about delta Y, delta T, and acceleration? You must just think about that. All right. For each question. So maybe you are going to do this one in one question 2-3 times, but always you are busy with 2 questions, not just simple 2 points and calculate. Of course, you are going to calculate here and then asking you another motion, but just simplify that with 2 points, initial and final. When you get V initial, delta Y, delta T, acceleration, or V final, and then one of them will not be given, you are going to calculate. That's it. All right. Just think simple, please. So these definitions we have, and then let's see what else they are saying here, just in object, okay. Let's just check as object project, okay, comes to rest, final rest is 0, highest point. Yes, this is the important one. This is another motion. First motion, what was it? Free fall, right? V initial equals 0, we said, and then object is going down. Okay, this is our first motion, but second one, object from ground and going up. So when object going to highest point, V final equals 0. So what we said, just always think you have 2 points, initial position, final position. For this motion, free fall, this is your initial, this is your V final. So this is your final position. V final is here. We are not working with numbers now, just I'm trying to explain how you make it easy. So now, for now, just check, this is your V initial, this is your V final. The initial V final, as you see, just opposite, but because I'm using 2 different equations, 2 different motions. So this is your V initial. We don't know how many meters per second, but you have V initial here. But V final for delta Y maximum is 0. V final equals 0 for this kind of motion. All right. So let's continue. Let's see what else we have. Please read, just go through all of them when you have time. All right, note 1, important point 1. Always choose a direction, positive. All right, so maybe upward motion is positive or downward motion, just motion is positive, but you must choose a direction and show that direction by using an arrow. Okay, that's important. Why? Because if you know direction of motion, easy to calculate. All right, for example, free fall. Okay, let's start with free fall. So V initial equals 0, let's say, and then we have V final is here, and then I'm just showing like this. I'm mostly using up positive. Okay, just using like this, up positive. If you say up positive, your acceleration is negative 9.8. Why? Because we know acceleration always downward and always 9.8. So you set up positive and your acceleration is negative. So how we are going to calculate V final? If you have, let's say, for 5 seconds, object is coming ground in 5 seconds. How we are going to calculate? So V final is equal to V initial plus A times delta T. And then V final equals, your V initial equals 0. And we set acceleration is minus. Why minus? Because I know accelerating down, the acceleration always just pulling down. So, but you set up positive. Because of that, acceleration is negative we are using. So minus 9.8 times 5. And your V final is equal to minus what we have, 49, right? 49 meter per second, but you are not living like that with negative. Negative, it always must stay away from us. So V final equals 49 meter per second. Sorry, not squares, meter per second, direction down. All right. So this negative is giving you direction because you said upward is positive. And then you got answer 49 meters per second downward. But I will show you, if you choose downward positive, what's going to happen? You should get same answer, exactly same answer. So downward is positive. This is your V initial is equal to 0 and object is going down. And then we are asking you delta T equals 5 meters per second. So sorry, I'm lost today. Delta t equals 5 seconds. And acceleration is positive 9.8 now. Why? Because I know direction of acceleration going down, always like that, right? Direction of acceleration down. So you said downward is positive, you are showing like this. So you are using positive 9.8 meter per second square. So we are getting V final. So V final is equal to V initial plus A times delta T, and V initial is equal to 0 plus 9.8 times 5, and you are getting 49 meter per second. I'll be writing up. Okay. And direction downward. Why? Because you got positive, and then we know positive is downward. Did you get it? I hope it's fine now. So choosing direction is important, but final answer must be same. Okay, using negative and positive just to show direction. If you choose upward positive, your acceleration is negative, because I know negative, because acceleration always down. I hope it is clear. So same steps to calculate our delta y. So delta y equals, you can use any equation. I will use last one, V initial plus V final over 2 times delta t. And so my V initial equals 0, V final is minus 49. All right. So I'm using that. Why? Because I said upward is positive. So divide by 2 times delta t. Delta t is what? Delta t is 5 seconds. So I'm using delta t. Let's write 5. So 49 over 2 times 5. You are getting your delta y is negative. And then you can say object is coming down. As you say, object is coming down. We are not calculating, but it's fine. So it's coming down, and then you are getting negative. Same steps. If you do this one for choosing downward positive, you are going to calculate delta y is equal to V initial plus V final over 2 times delta t, and you will get positive. So why? Because object is coming down, and then you said downward is positive. I hope it's clear what we said just from note 1. I'm trying to explain note 1, choosing direction. All right, and just show like this. Final answer must be same. Okay, that's clear. Time is going. Note 2, acceleration is constant and always downward. All right, even if they ask you highest point, what's the acceleration? I remember in past paper question they asked. So acceleration is constant and always downward. Remember that. Or moving upward or downward, object is moving somewhere. It's not important. But remember, if you choose upward motion is positive, your acceleration is negative 9.8. We explained in other slide. And then if you just choose downward motion is positive, you say positive, because they are having same direction. If you choose downward positive for direction. All right. And then next one, let's continue with next question. Next question is coming. Okay, so next, not question, note 3. Velocity of an object becomes 0 when it reaches the maximum height. Yes, object will be 0 when object is coming to maximum height. Okay, that's our another important point. Okay, that's another important point we just explained now. So if object going up and coming to maximum height, so this position, your velocity, let's say V final is equal to 0 if you choose V initial. Remember, you can choose, we are busy with 2 points, right? Always we are busy with 2 points. Maybe object moving from certain height, going up and coming down. So for this kind of questions, you can choose initial position here, final position, that's all. Or you can choose initial here, final there. Or you can choose initial at maximum height, and it's up to you, it's up to your calculation, which one you like. But in this note, they said velocity of an object becomes 0 when it reaches the maximum height. Okay, let's continue. Let's see what else we have. Note 4. Time is a scalar quantity and no direction is used. Remember that. And then if you are getting negative time, it means some calculation is wrong. Just remember that. All right. And note 5, negative value just showing you direction. Depends on which direction you are choosing, which one is positive. Just remember that. And then let's continue with next one, note 6. Objects at the ground with highest velocity. All right, highest velocity at the moment objects reach the ground. When object is coming to ground, okay, highest velocity, highest kinetic energy. Just remember that. So we can just show, but okay. So object is coming from here, let's say the initial, and then going up, change to 0, and coming down. So when it's coming back, so this position before touching ground, V final equals negative V initial. It means just opposite direction of first one, but same magnitude. If it's going up with 10 meters per second, coming down negative 10 meters per second. Only direction is different, but they have same. And then highest point we have same O. Okay, let's continue with next one. Let's see what else we have. Graph. Yes, from now, we just work on with graph. And then let's see what we have. Uniform motion. What does it mean, uniform motion? Acceleration is 0. As you see in our graph, acceleration is 0. Acceleration is 0. Acceleration equals 0. But velocity is constant. You have two options. Velocity is positive or negative. Velocity is positive, your position change to positive. So you are changing position from 0 to, but depends on reference point, which one you are starting, where you are starting. From 0, just increase. Maybe you start from this point, of course, also increasing, but position change, positive. And then another option, your velocity is negative, but constant, you are coming back. Okay, so for example, from 10 meters up, you're coming down to 0 meters. Uniform motion means acceleration is 0. Velocity is constant. But another one, for uniformly accelerated motion, now you have acceleration. You have two options. Acceleration is negative or acceleration is positive. If acceleration is negative, velocity decreasing, as you see, from 0 to negative. And then if acceleration is positive, as you see, from negative to 0 now. As you see, increasing. All right, velocity increasing. And then your position time graph will be like this. Coming, as you see, speed up, and then firstly changing slowly position, finally just speed up, and another one this way. So this is position also change, but making curve, just remember that. Okay, and then bouncing is coming now. If you have one object is coming down, let's say just drop from certain height, okay. So you have just an object from certain height coming down first. After that, bounce up. So what's going on? Just let's show like this. Bounce up, it's coming to second position. Again, it's coming down, bounce up. But each touching time, as you see, position time graph like this. Firstly, speed up and coming down, touch the ground, and waiting just maybe less than a second. This one is touching time of contact. So this position, as you see, position never changes, just staying, just let's say 1 second, just staying 1 second and then going up. So just each time getting less high. All right, another touching point here, and another one from 0, it is just going down, okay, just going down, and then another position that's touching somewhere and coming back. So you are just reference position of drop from reference point. So what's the difference between these two graphs? First one, you are choosing this position 0, all right. But for this one, you are choosing certain height. For example, here, just this position. This one you are choosing as 0. If it is your 0 position, object going down. So going down, you set this position 0, and then coming back, coming closer, but not to same height. It's coming up. Another one after call is just coming, just up like this. Okay, so making curve and then changing position like this is our position time graph. And then velocity time graph, what's going on? Firstly, velocity coming to negative. If you choose upward is positive, you say. So velocity getting negative now because the object is coming down. Okay, so this position like this, from 0 and coming down and then going up, but getting less velocity. So contact time we have, if there's no contact straight, you can go up. So the contact, just you can do this one, but firstly going up because velocity getting positive, because when after touching, as you see, changing direction. When changing direction, change to positive and then coming down and then with less velocity and then again, just carry on like this. If you say downward positive, what's going on? If you just show like this, downward positive velocity, as you see, increasing, velocity increasing, and then when touching ground, changing position, going up now from the point D, as you see, going up. If it is going up, as you see, negative now. Why negative? Because we said downward is positive. So just like this, you can draw your velocity time graph. Some important points here. So V initial is the velocity just before its ground. V initial is here, touching ground position A, point A, and different important points we have. Hits the ground at points A, B, C. As you see, A, B, C, touching ground, and then D, E, F, showing you another one. Okay, let's continue. All right, let's continue. This is our velocity time graph. Okay, we have done velocity time graph also. And let's see what else we have. Let's clear all. Acceleration time graph. Acceleration time graph for bouncing, it's happening like this. For example, you trace upward positive, so you are starting with negative acceleration. And then when touching, so as you see, just going up, change to positive and coming down, just like that. And downward positive, you start with positive and then change to negative quickly, a few seconds, and then coming back. This is acceleration time graph. And then let's continue with questions. Let's give examples. Okay, so from now, what you are going to do, please go to past paper questions and I will give you one example, one multiple choice question, and one long question, well, one example for each. So let's see our first question. The graph shows how just one of physical quantity with free fall. Okay, for free fall, as you see, it is constant. For free fall, what we know, what is constant? Acceleration is constant. So what they ask you now, which one of the following physical quantity can be labeled on the y-axis? So what else can be constant? Asking you that question. I know acceleration is constant. It is G 9.8 meter per second squared. So this which one depends on acceleration? Velocity, is it constant for free fall? No. And position, constant for free fall? No. Momentum, constant for free fall? No, because momentum equals m times v. We know that velocity increasing, velocity changing, momentum also getting different, but weight is constant because weight equals m times g. Mass is constant, g is constant, weight is constant. That's our answer for this question. You can say weights, newtons, and times second. You can draw your graph. All right, I hope it's clear. So let's continue with other question. Long questions coming now. Okay, you have one object, start with 8 meters per second, and then going up to highest point. We know when it's coming to highest point is 0 velocity, and coming down to height 8, and initial position 60 meters, bouncing from there and going up and coming to ground. So that's our motion. So is the object acceleration at its maximum height? Upward, downward, or 0? What we said, acceleration always downward. That's it. First answer is downward. And then next question. Calculate the magnitude of the velocity at which the object strike the balcony. So we are looking for velocity for this point when touching the balcony. Okay, let's show this position velocity we are looking for. How can we calculate? We have different options for this question. We have too many options. Let's see. Upward positive. If you say upward positive, you can use this way. V final is equal to V initial plus A times delta T. What we said, we remember, always choose your 2 points. First point, your initial position. First point is your initial position. Second point is your final position. Object is going up and coming. If you want, you can choose, this is my final position, calculate something there and coming, but easy way, it is my initial position and this is my final position. So for initial position, what's my V initial is 8 meters per second. On the diagram or on your solution, if you write like this, it's going to be very easy for you. I am looking for V final for this point. V final, we are going to calculate. What else I know, if I say upward positive, you can write like this, upward positive, or you can show just with arrow and sign, also fine. If upward positive, what I know, acceleration is negative, because acceleration always down, and then you said up is positive. So you are using negative, and then you are getting negative 31.2 using first formula, V final equals V initial plus A times delta T. I am using these 2 points, and then V final equals minus 31.2, because as you see, finally you are going down. So as you see, direction is this way. This arrow showing you after bouncing is going up, all right? So you are using this one, let's show, going up and coming down. So this is your final position. All right, I hope it's clear. V initial, V final, delta T already given. They said after 4 seconds coming to height h, 4 seconds we have. V initial we know already, 8 meters per second. Positive I'm using because direction of motion and direction of velocity V initial and direction of, you said positive, upward positive. All right. So if you say downward positive, what's going to happen? V initial is negative now. Why? Because you are saying downward positive. Okay, let's use downward positive. So object is going up initially. So negative 8. But your acceleration is positive because acceleration always down. So you are getting 31.2. As you see, you are final, you are getting same answer. Just remove if you get negative. Remove and say. And if they said magnitude, because of that, you don't have to say direction. But if they don't say magnitude, just calculate velocity. What we have to say, you get positive, so negative answer. Because of that, you should say downwards. All right, for this answer, just say downward. And now you get positive, but you said downward is positive. So answer is downward. So you are just getting same answer, even same direction. I hope it's clear. We are using our first equation. What we said, 2 points important for you, just using initial and final. All right, let's continue with next one. Okay, let's see what else they're asking you. Now asking you to calculate that height. Okay, this height we are going to calculate. How we are going to calculate that? One more time. I am choosing my 2 points. Okay, now which 2 points I'm going to use? This is not A by mistake. We wrote A. This is V initial. All right, V initial. Even this one, let's change it. V initial. Okay, so now, as we see, in 4 seconds coming down, I'm using delta Y for this one. Okay, for initial, same motion, same 2 points I'm using, calculating this delta Y. When you get this delta Y, just subtract from 60 meters, because just you are calculating the another equation I'm using. So this is my initial point, this is my final. If you say upward positive, your V initial is positive, delta T already positive because always positive, and 1/2 times negative 9.8 because you said up positive. So you are just calculating negative 46.4 and 60 minus 46.2 because delta Y, forget about this negative one, just showing you directions, remember that? So 60 minus 46 and you are getting 13.6. Another one, if you say downward positive, V initial is negative now, remember other question, and times delta, just times by 4, and acceleration is positive now, and then you are getting your, you should get positive, sorry. Okay, you are getting positive because you said downward positive. So mistakes, 3 mistakes in this question. Okay, and then you are getting 60 minus 46.4. I hope it is clear. So please think simple and make it simple and get your answer. Use 2 points, initial and final. Even if they are giving you 2 different objects, first one, second one, just separate them, calculate different. Okay, just use, okay, for A, what's my initial position, final position, get something, calculate, and then maybe you can use that one for another object, but same process for all questions. Okay, let's continue with next one. Now we are gonna draw graph, velocity time graph. So object bounced from balcony 27.13 meters per second, all right. And then in 6 seconds, okay, coming to ground. Okay, so they're asking you draw graph. Let's see our graph now. I think we have done after this. Yes. So now we are drawing what we know. Initial velocity is 8. And then velocity coming to 0 because going to highest point. This point is highest point. This is my highest point. And then coming down from highest point to negative 31.2 we calculate in 4 seconds. See, this is my first one. And then strike and going up. So going to 27 because they said after bounce it's coming to 27.13 meter per second. So coming to positive, after that, going to 0 again. So this motion we can show with our diagram. Okay, it's coming back and then in 10 seconds complete, or because they said after bouncing 6 seconds, 4 seconds already gone, extra 6 seconds, total 10 seconds. Firstly, maybe we can draw. Firstly, you start with 8 meters per second. Okay, let's try to draw here. This is my point, just height 8. Firstly, starting with 8 meters per second up, we said upward positive, so now you have positive 8, and then going to 0, because highest point we know it is 0, this is your highest point, and then coming down to H, this balcony, this position, we know it's touching that level with 31.2, negative, because direction is negative, up is positive, we said. So, and then it's bouncing with, they said, bouncing with 27.13, it is given. So this is my V initial for this point. And then going up again, change to 0 and going to ground. I hope it is clear. Just this change, remember, was because direction getting different, direction getting opposite direction. All criteria to get full mark. Please draw your graph nicely. All right, we have done for today. Projectile motion also done. See you next lesson. Hi everyone, welcome back. Today, quick revision for work, energy, and power. So we are gonna start now without wasting time. And first of all, as you know, we are starting with definitions. So work, power, work energy theorem, conservative force, non-conservative force, conservation of mechanical energy, and mechanical energy. All definitions here. Please study, please try to memorize. Nothing to do, we should know them all. All right, let's continue with next one. How we are gonna calculate work? Work is the product of force and displacement in the direction of force. So that one is giving you cos. We are using cos for this question, for just calculating work. Work is a scalar quantity. Unit of work is joules, you know. And then if the angle is 180 degrees, the work is negative. So let's explain that now. Let's see. As you see, we have only apply force here. Let's say F apply. F apply, work done by apply force equals F apply times delta x times cos angle. But if we say object, object is moving this way. Okay, if object is moving this way, as you see, F apply and direction of motion same. If you have two vectors, same direction, let's draw like this. As you see, angle between these two is 0. So work done by apply force is equal to F apply times delta x times cos 0 we are using. Why 0? Because there is no angle between these two vectors. So you can say just positive 1. This is positive 1. You are using cos 0. But let's say we have friction force on the surface. You have friction force, but now, as you see, opposite direction of motion. So what is work done by friction force? Friction force equals work done by friction force is equal to friction force times delta x times cos 180 degrees. Why 180? Because direction of motion vector this way and friction force vector this way, F, and let's say acceleration or velocity is fine, direction of motion showing. As you see, angle between these two is 180. And then we know cos 180 is -1. Because of that, you are getting negative. Work is negative. I hope it's okay now. But if you have other apply force, if you apply force with angle, let's continue. Today we are tired. Huh? Okay, so total work done, net work. So we are going to work energy theorem and other things now. You have these forces. Okay, so let's try to get work net work for each force. Work done by applied force plus work done by normal force plus work done by friction force plus work done by gravitational force. Work done by normal force and work done by gravitational force will be 0. You are going to say, you are going to ask why? Because direction of motion, if this way or other way, it's fine. Direction of motion, let's use to the right. And gravitational force going down. Angle between these two is what? 90 degrees. So, F gravitational force times delta x times cos 90 is 0 because we know cos 90 equals 0. Normal force also same stuff. So the direction of motion this way, normal force going up. As you see, angle between these two is 90 and making 0. So we don't need to calculate normal force work done by and gravitational force. We don't need because of 90 cos 90 making 0. I hope it's okay. So to get work net, only parallel one we are using. Work net equals work F apply plus work done by friction force. But F apply with angle also. Let's use alpha, another angle here. So if you have angle with apply force, so you are using only F apply parallel. So it means you are using F apply times what we have cos alpha. Okay, F apply times cos alpha we are using. Let's write nice. F apply times cos alpha I'm using. Let's write here F apply parallel is equal to F apply times cos alpha. Okay, this cos is different one, all right? So this, we are going to have two cos. So work done by apply force for parallel one, as you see. Work, okay, it's here. So how I'm going to write, let's continue from this point. A work done by apply force plus work done by friction force is equal to F apply times cos alpha. You are writing component first. Times delta x times cos 0. All right, so first of all, you are getting F apply perpendicular, so F apply parallel, and then times by delta x, and then times by cos 0, and plus friction force times delta x times cos 180. All right, so just remember, if direction of force and direction of motion same, you are using cos 0. But if you have angle and components, you must just get a parallel first, and then times by delta x, and then times by cos 0. All right, so, and another option to calculate net work, you can use mechanics. Firstly, you can get net force. What's our net force? F net equals F apply parallel minus friction force. What is F apply parallel? F apply parallel is equal to F apply times cos alpha. Okay, F apply times cos alpha minus friction force. This is our net force. And then to get net work, you are writing F apply times cos alpha minus friction force times delta x times cos 0. If opposite direction of motion, F net must be opposite, same direction of, sorry, not opposite, same direction, so cos 0. So this is our work net. All right, what we are doing, so apply force times by distance times by cos 0 if they have same direction. And then for friction force, as you see, I didn't use for friction because we calculate already F net. All right, straight I'm using F net. For this one, I'm just using F net. F net moving delta x meters. So straight I'm using F net times by delta x and cos 0 degrees. So for friction force, 180. Angle is 180. Okay, let's clear all and let's check one more time. Work net equals work done by applied force plus work done by normal force plus work done by friction force plus work done by gravitational force. But we know normal force and gravitational force work 0 because of 90 degrees. And then work done by applied force, F applied times delta x times cos 0. And then for friction force, cos 180. I hope it's okay. Let's continue with next one. Let's see what else we have. Yes, mechanical energy. You know already mechanical energy from, let's see. Okay, something wrong. Let's just try again. All right, let's continue with mechanical energy. Mechanical energy is the sum of the kinetic energy and gravitational potential energy. And kinetic energy of an object is the energy, just energy of motion, we can say, formula is here. And kinetic energy, other formula we can get with momentum. So kinetic energy, energy of motion. Gravitational potential energy, stored energy, m times g times h, depends on height. And energy is the capacity of a body to the work. And mechanical energy is the sum of the kinetic energy and gravitational energy. You know that. Unit of energy, SI unit of energy is joules. So we can carry on. Work energy theorem is another one. Work energy total work or net work, you can say. Net work done on an object is equal to the change in kinetic energy of the object. Work done equals change in kinetic energy. This is our formula. Work net delta EK. When you check past paper questions, we put just some different questions you can see about that. So sometimes they are giving you total, just they are giving you force and you are calculating work net work, and then asking you maybe V final, maybe V initial, or the delta EK, change in kinetic energy is given. You can see on your, just on past paper questions, delta EK is given, asking you force or, because work net formula we know, F times delta X times cos 0 or just say angle. So equals this one over 2. Okay, let me just do this. So F times delta X times cos 0 or cos angle, let's say. So you are using this equation to get force or to get delta X or even the angle they can ask. So the angle 0 or 180 is fine. So maybe this side is given, work net is given, asking you V final, or V final, V initial, even delta EK straight, change in kinetic energy given, asking you delta X or force. Different kind of questions they can ask. And then conservation of energy. Energy cannot be created or destroyed, but maybe transformed from one form to another. And conservation of mechanical energy. The total mechanical energy is an isolated system, remains constant. So mechanical energy total. So what's going on for this kind of questions? Just object changing position, maybe from first position and coming down, and then asking you for first position and second position, what is initial height, final height, most of stuff given, only one unknown, you are calculating. Okay, conservation of mechanical energy, conservation of energy, work energy theorem, everything is here. So let's continue with next one. So work energy theorem I put again here because we have energy principle now, energy theorem, just energy principle. So conservative force and non-conservative force we have. We have two different types of forces. Conservative force It is defined as a force for which the work done is moving an object between 2 points is independent of the path taken. So examples, gravitational force, elastic force, just spring, electrostatic force, we can say non-contact forces. All right, non-contact forces, conservative force. And then non-conservative force, contact forces. So now you have friction force, air resistance, tension, apply force. In past papers, sometimes they're asking you what kind of force you have, and then which one is contact force, which one is conservative force, which one is non-conservative force. If they ask you energy principle, just use energy principle. So you must use this formula, work MC, delta EK, delta EP, change in kinetic energy plus change in potential energy. But if they ask work done, work energy theorem using, only work net equals delta EK. So different questions we have, work energy theorem and energy principle. So two different formula, both of them you are having in your formula box. So these are two different formula. Please remember, work energy theorem only change in kinetic energy, energy principle with kinetic energy, change in kinetic energy plus change in potential energy. All right, we have done. Let's continue. Power is last one. Power is the rate at which the work is done or energy expended. So work over time is giving you power. What is the unit of power? Unit of power is watts. What is the unit of power? Just remember that. Okay, so let's continue with examples now. Let's see our first example. I hope everything is clear about work energy topic. So if the net work done on a moving object is positive, then we can say the kinetic energy of the object, what we can say is zero, has increased, has decreased, has not changed. Has not changed is zero, is same thing. Okay. So, kinetic energy, okay, kinetic energy. Kinetic energy increase, decrease, or same, or zero. What do you think about that? So now you have work net. Net work is positive. Work net positive means your kinetic energy increase, just like this one. So you have V initial, let's say 0, and the velocity increasing, coming down, and then your kinetic energy increasing, because positive means your kinetic energy, your delta EK is positive, because what we know, work energy theorem, so work net is equal to delta EK. So delta EK positive. It means EK final minus EK initial is positive. So EK is more than EK initial. EK final is more than EK initial. So has increased. That's our answer. Is zero? No. Decrease? No. Not change? No. All right. I hope it's clear. So positive means, so positive, they said positive, direction of motion and that force, same direction. What direction of motion and force, same direction. They are moving to same direction, let's say. And then that time making positive motion. And then kinetic energy increasing. If kinetic energy increasing, your work net work is positive. I hope it's clear. Okay, let's continue with next one. Now another question. They said, okay, this object, what's going on? 75 kg object, initial rest, okay, on the ground, okay, first, and then going up with 0.65 meter per second. Acceleration, okay, with accelerating, all right, we know acceleration. And then no air resistance, okay. Mass is given, 12 meters going up. Draw a labeled free body diagram. As you know, free body diagram, force diagram in mechanics, we know already, right? So you are showing all forces on the object with dot free body diagram, maybe force diagram as you see coming back, force diagram, free body diagram. So we can draw, it's easy one. And then what they ask, name the non-conservative force. Okay, non-conservative force. What was the non-conservative force? Contact forces. Contact forces, friction force, tension force, or apply force, whatever we have here, we can check. And then calculate the work done on the load. So we are going to calculate work done by the gravitational force. So we are calculating work done by the gravitational force. All right. State the work energy theorem, okay, because from our definitions, we should know work energy theorem. So other definitions also, you know, and use the work energy theorem. All right, we are using it now. Work energy theorem, calculate the speed of load. Remember we said they can ask you, changing kinetic energy is given, asking you displacement. Changing kinetic energy is given, asking you force. You know, that kind of question. But now, what is given? Work done, you calculate already, you're going to calculate there, and then you are using that work done to calculate speeds when it is just height 12 meters. Okay, different calculations, but same formula we are using. Okay, let's see, draw free body diagram. On this object, as you see, what forces we have? Let's check. We have, as you see, we have tension force going up, and then gravitational force going down. If they ask you free body diagram or force diagram, please draw on the system first, and then you can see what kind of forces you have. You have tension force and work, so not work now, gravitational force you have. So you can show you like this. This is our free body diagram. If they ask you force diagram, you can draw object here. Even they accept this, but just don't take risk. So draw like this is much better. You are drawing your objects and showing forces. This is force diagram. But you must label them, all right? So don't forget to label them, just like mechanics topic. Okay, and then name the non-conservative force. As you see, we have tension force here. Non-conservative force is tension force. But if you say apply force, also working, so also accepted. And then, but if they ask you, name the conservative force, what you are going to say? Gravitational force. Non-conservative force, tension force. Calculate the work done on the load by the gravitational force. Okay, this is our formula. Work equals force times delta x times cos something. And then m times g, we have a force, as you see, gravitational force, m times g. M times g times delta x, already 12, we know. And cos 180. Why cos 180? Because as you see, object is going up. Acceleration, direction going up. And then your gravitational force going down. And angle between these two, 180 degrees. Is it clear? Let's say yes. All right. And then, so you are calculating work done by gravitational force. And then negative, you are getting negative. It means because you are getting negative, and then you can say velocity decreasing. Yeah, opposite direction. Yeah, velocity. Okay, negative. Oh, okay. Because opposite direction, gravitational force, opposite direction of motion. Gravitational force trying to pull it down. Okay, the opposite direction because of course, negative. And then next one, state work energy theorem. Next question. Work energy theorem definition you should know from our definitions, please. Definition list, just get it and study, please. Just try to memorize. And next one, use work energy theorem. Okay, what we know work energy theorem, work net equals delta EK, yes. Work F net times delta X times cos angle is equal to 1/2 times M times V final squared. So now they're asking you, right, V final. See, this kind of questions, they're asking too many questions about this. So now what is given? F net is given, delta X is given, cos 0 you are using, because you are using which one now? Cos 0, work done by tension force, acceleration. So net force, you are using net force because net force going up. F net is equal to tension force minus gravitational force, using minus gravitational force. So same direction of acceleration, because of that cos 0 we are using 1/2 M times V final square minus V initial, and then you are getting V final. All right, you are using this way. Different options, of course, you can use. So, but if they ask you use energy principle, what you are going to do? Energy principle, that time you must use work and C equals delta EK plus delta EP. All right, so please remember that also. So different questions, different types of questions they can ask. Please check all other questions on your textbook, all examples. They're all past paper questions. Please try. I think we have done for today. Yes, thank you very much. See you next lesson. Good luck for all exams. Hi everyone, action time, grade 12. Let's start. Doppler effect, introduction, and examples. So we are going to explain what is Doppler effect, but before that, let's go back to grade 10. So let's see what we know, what we have to remember from grade 10. First of all, we have a wave, first wave and second wave, so two waves total, and highest point on a wave, what we said, crest. And then zero position and distance between zero position and crest is amplitude. So just to remember, we are giving this all the information. Throw is lowest point in a wave. And in this diagram, how many waves we have? Two waves, we said. And then from highest point to highest point, you are getting wavelength. Amplitude is here. Okay, step by step we can carry on. Okay, amplitude is the maximum displacement from zero position to a crest or a throat. So this is amplitude. A unit of amplitude is meter. Let's continue. Next one, distance between two successive crest or throat is wavelength. Wavelength, length of wave. So it is, but this is important one for our Doppler effect, starting with this one, because most of questions coming with frequency and wavelength. Because of that, we should know what is wavelength, length of wave. So from crest to crest, or from throat to throat, and or from first position, so first point, firstly wave is going to positive, making positive pulse, and negative pulse, one, completing one wave. This is also wavelength. All right, all together also wavelength, distance between two successive crests or through called wavelength. So we are going to learn between wavelength and frequency, and we are going to use wavelength and frequency in our questions. Wavelength symbol meet all. Okay, sorry. Let's show symbol, just using this symbol. It is here. And then unit meter, because it is distance. Next one is frequency. Frequency is the number of complete cycles. All right. Frequency is the number of complete cycles that pass a given point per unit time. Number of complete cycles in a second, we can say. Symbol of frequency, we are using F. Hertz is unit, and second power of -1 is another unit, because coming from 1/T period, yeah, it's coming from here. Period is the time. Frequency is number, all right. Period, symbol T, capital T we are using. Time for one wave. Time for one wave. Full definition is here. Time needed to complete cycle or form a complete wave. So this is period, and period unit is second. And frequency and period formula is coming now. This will be now, yes. Frequency equals 1/T, or T equals 1/F. So this is our formula between frequency and period is here. Another one, we have another formula, another important one, speed. Speed of the wave. Speed equals wavelength times frequency, or because we know already F equals 1/T, you can write V equals wavelength over T. These are formula we should know, we should remember. Frequency equals 1/T. T equals 1/F. F is number of waves in a second, and T is time for one wave. For example, in this question, if I said two waves complete in 5 seconds, so your total time, let's show with small t, total time is 5 seconds. What's our period? What's our capital T? So for one wave, right? We are going to write number of waves. We have two waves here. So you can get period. Period is equal to time over number of waves. And then 5/2 equals 2,5 seconds. For one wave, our time is 2,5 seconds. If your time is period is 2,5 seconds, what is your frequency? Frequency is equal to 1/2,5. And then you can write what we are getting for, right? 4hz. I hope it is clear. Time, total time, period, time over number of waves, or another option to get frequency from grade 10, you remember that, n over t. N is number of waves. Number of waves we have 2. T is equal to, time is equal, okay, just 1 minute. We should recalculate, double check. Just this double check. Yeah, we should double check, we said, because we did mistake here, 0.48Z. And then another option, frequency n over t, number of waves over time, so 2 over 5, and you are getting 0.4hz, not 4, we did mistake there. So okay, we fix it now. So 1 over t giving you frequency, or number of waves over time is giving you frequency also. These questions, not for metric, just we should remember, okay, just wavelength, period, frequency, because of that we are answering this kind of questions. Let's continue. What else we have to know? Yes, now we are going to Doppler effect. Okay, so what we have for Doppler effect, we have listener, just we said L, and we have sound source. Crazy man is here, just moving with car, just and then driving a car and making noise. So listener is here. Okay, let's work with this one first. If going away from listener, source of sound, going away from listener, let's show like this, going away from listener, making long wavelength, low frequency. Normally frequency, let's say 10hz. 10hz. This listener first, let's say L1, L2, for example. L1 will feel maybe 9hz. It's just, we are going to calculate later, but for now, just to understand, a frequency for listener 1 will be less, low frequency. But if the L2, just it's going to this side, it is going to listener 2, and then of course, we'll get more frequency, plus minus, let's say 11. Maybe just listener 2 will hear 11hz. It means it is going away, low frequency, less frequency. It is coming closer, high frequency. We should just remember this point. But for wavelength, opposite. Why? Because wavelength and frequency, just let's draw our waves. For example, here, just if you have a wave like this and then slowly coming close to each other. So now you have long wavelengths, but low frequency. Frequency, what was the frequency? Number of waves in 1 second. If we say this one, let's complete 1, 2 waves like this. If you have, as you see, just check this 2 time distance. If we have more waves here, but short wavelengths. As you see, first position, L1, low frequency. Firstly, low frequency, going away, low frequency. Just remember that. Going away, low frequency, but long wavelength. And then, if it is coming to listener, source of sound just coming to listener, short wavelength. Okay, let's draw maybe separate, we can draw. Okay, this is like this. Other one, see, I couldn't draw well, but it's, you are getting it. So firstly, you have long wavelength, but you have only 1.5, just less, low frequency, less number of waves. But now when you come this side, you have short wavelengths here, but number of waves, we have too many waves, high frequency. Coming closer, more frequency, that's it. Okay, let's try to listen now. All right, let's continue. So first of all, our example is coming now. As you see, when it's coming closer, frequency increasing, When it's going away, source of sound going away, frequency decreasing, but wavelength opposite. Just remember that. When it is coming, wavelength getting longer. Longer or shorter? Yes, shorter. Okay. Yes. When source of sound is coming to you, frequency increasing. If frequency increasing, what about wavelength? Wavelength getting shorter. But when source of sound going away from you, frequency getting low, getting less, but wavelength getting longer. All right, when frequency increase, when source of sound coming to you. And then when frequency decrease, when source of sound going away from you. Another example. Yes, I think it's enough. Just we should remember all examples, what's going on. Okay, with this formula also we can show if it is going away from you, low frequency, long wavelength. Coming closer to you, high frequency, short wavelength. Please try to keep in your mind. And then we have only this formula for Doppler effect, but it is coming with plus minus. What does it mean plus minus? Just to explain when we are using plus, when we are using minus. So we are going to use two different points. All right, to understand this question, let's say we have source of sound and listener. So firstly, let's say if I said Fs, you understand, right? Frequency of source. And then Fl, frequency just getting by listener. What frequency you can hear, what frequency you are getting by listener observer. So this is Fl. And then Vl, speed of listener. Let's write this side. And then we have Vs. Vs is speed of source. And what else we have? Fs, Fl, and V. V is speed of sound. Speed of sound 340, 345, depends if it is given in question or you are going to calculate, but this one is plus minus 340. We have Fl, frequency by listener, what frequency getting, and then Vl, speed of listener, Vs, speed of sound, Fs, frequency of speed of source, frequency of source. Okay, examples. Let's continue with examples. Just remember, now more details here. Yes, we have frequency detected by listener, Fl, Fs is equal to frequency produced by the source, speed of sound, and speed of listener, and speed of source. And Vl is station. From now, different examples, when we are going to use plus, minus details coming, we have three options. All right, case 1, case 2, case 3, we can say. In other slide, let's see what we have. Okay, the definition is coming now. Okay, for this kind of questions, when we are going to use plus, when we are going to use minus, let's explain, and then let's give definition, and then let's start answering our questions. First of all, case 1. Case 1. So, firstly, let's say source of sound and listener, both of them stationary. So Fs equals 0, so Vs equals 0, Vl equals 0, and then let's say Fs equals 28 Hz. We have sound, we have frequency, but both of them stationary. Let's use just any of this, none of them is moving. Source of sound and listener, both of them not moving. This position, just think about that. You have 0 here and 0 this one. And you have, what we said, 20. And then V and V also, just V over V you will get 1. So your FL equals 28 cents. So you don't need to calculate. You don't need to use this formula. Just remember, for case 1, both of them stationary. Source of sound, ambulance or petrol car, something, just making noise coming to you. Or the first case 1, just both of you, source of sound and listener, both of them not moving. For this case, we have same frequency, same wavelength also. Let's say wavelength is equal to 0.5 something, just writing number. So L wavelength for source and listener will be same meters, sorry. I hope it's clear. Case 1, remember, we have listener, we don't need these two guys now. Let's make just 1. Let's remove one of this. I hope case 1 is okay. Both of them stationary. Because of that, FL, FS, same. If you have 28Z, you have 28Z for FL, because this is 0, and they cancel each other, speed of sound. So this is our case 1. One more time, let's say VL equals 0, VS equals 0, and what we know, Fs is equal to Fl. This is our case 1, both stationary. Let's continue with case 2. What's going to happen now? Case 2, source of sound is coming to listener. Okay, this is our source of sound. Let's say S here and listener here. This is our case 2, coming closer, approaching. So this time, now we are gonna just busy with plus minus. What's gonna happen now? So what we know, when it's coming to you, what's gonna happen? Frequency will increase. Remember, frequency will increase. What about wavelength? Wavelength will decrease, just getting less, getting shorter. So frequency increase for this case. Just source of sound coming closer. All right. So now frequency increasing, getting higher, and wavelength decreasing, getting shorter. And our formula, what's going to happen? If frequency increasing, you are going to write our formula like this. F equals V, speed of sound, plus VL, we are going to say. VL, speed for listener, and they're approaching each other. We don't know. Maybe the car is moving. Maybe listener is moving. Maybe both of them moving. Doesn't matter. Just case 2. What we have to keep in our mind, they are coming closer. They are moving to each other. All right. This is case 2. So V plus VL over V minus VS. Why? Because I know FL and on top V plus VL directly proportional each other, so this side must increase. And this are inversely proportional each other, so this one must decrease, and then FL will increase. So this formula we are going to use. All right, for case 2, when you see in the question they are coming close to each other, remember V plus VL, plus minus, just remember plus minus. So plus on top and then minus down. So V plus VL, V minus VS. Please try to remember. Otherwise, you are going to use different sign, plus minus. You are going to confuse, so you are going to get lost. This is our case 2. Case 1, what was it? VL, VS, both 0. They were stationary. And then you have FL equals FS. So source of sound, frequency of sound, and then frequency by listener, just both of them same. But now this formula we are using for case 2. And then what about wavelength? Wavelength, there's no formula here, but what we know, wavelength decreasing when it's coming closer, because if it starts like this, and then when it's coming closer, just like this. So getting shorter, wavelength getting shorter, frequency increasing. This is our case 2. You can say, we understand why you repeat, because it is very important. You know, most of questions you are answering with case 2 and case 3. All right, case 2, when source of sound coming to you, we are using this formula. I hope it is clear. Let's continue with next one. Case 3 is coming now. Case 3, let's see what's going on. Yes, now source of sound is going away from listener. As you see, going this way, and listener is here, sometimes stationary, sometimes going other way. But case 3, let's write listener. This is our case 3, going away from each other. If they are going away from each other, what we know, frequency will decrease. All right. If frequency decreasing, wavelength will increase, because we know, because of this formula, V is equal to F times wavelength. So we know this formula, and then frequency, if frequency increase, wavelength decrease. But now, when frequency decrease, wavelength will increase, getting longer. So we can draw also here, firstly like this, but finally getting longer. I hope it is clear. Wavelength getting longer, but frequency getting less. What was the frequency? Number of waves in 1 second. As you see, getting less number. But what about our formula? FL equals, as you know, I hope you are getting it now, V minus VL, because frequency getting less. Minus VL, other one will be plus. Now, minus plus. I hope it is clear. Now you are getting it. So from now, we are going to start. We are going to answer our questions. More details, you can read some stories about Doppler effect, but formula like this, calculation like this, we are using this formula, these two formula mostly. And then we have another formula. What was it? F is equal to 1 over T if they ask about a period. And then anything else? No, just like this kind of formula we are using in this kind of question. This is case 3. Sorry, I said case 2. This is case 3. Yes. Case 1, both stationary. Case 1, maybe we can show everything in one page, and then we can start. We can answer our questions. Let's clear all in one page. Okay. Definitions also you can start at the same time. Okay, we have 3 different cases. Case 1. Case 1, what we have, VL equals 0, VS equals 0, FL equals FS. All right, this is case 1. What was the case 2? Case 2, they are coming to each other. Source of sound and listener, they are coming to each other. Maybe one stationary, other one is coming, maybe both coming to each other, but they are approaching each other. They are coming to each other. So this position, what is our formula? FL is equal to V plus VL over V minus VS times Fs. To calculate FL, we are using this formula. After that, if they ask you calculate wavelength, you are going to use this formula, Vf times wavelength. You can say wavelength is equal to V over F. You can use this formula to get wavelength. All right. So wavelength, but wavelength getting shorter. Remember that, because frequency increasing for case 2. Case 3, we have, for case 3, what we know, they are going away from each other. Source of energy and listener, they are going away from each other. So this position, our formula is V minus VL over V plus VS times Fs. Same steps. If you need to get wavelength, this formula you are getting to get wavelength. We have case 1, 2, 3, done. And definition of Doppler effect is coming almost every year, defined. We have different definitions from different past papers I took, and then I just put them here. The change in frequency or pitch, because pitch, you know, frequency of sound. And the frequency of sound detected by the listener, because of the sound source and listen have different velocities relative to medium of sound. You just read and memorize them all, memorize them. Just one of them, which one is easy for you, can memorize, or just in case you know all of them. A change in observed frequency due to relative motion between the observer or listener, you can say, and sound source. Another one, a change in observed frequency because of the sound source and observer have different velocities with respect to medium. So 3 different definitions. Which one you like? Keep in your mind 2 marks plus minus coming to you during your exams. All right, definitions also done. Now we can continue with our questions. Question 1. Okay, let's see what they are asking. These questions from past papers. Today I will try to give you 4 examples, 4 past paper questions. Number 1, question 1. Okay, the alarm of vehicle parked next to straight horizontal road goes. Okay, let's read question. What we know from question? We know wavelengths. Okay, wavelength is given. Let's write all givens. This is best for you. All right, write with symbol what is given. So what we know for this kind of questions, we have 2 points: sound, source of sound, and listener. So wavelength, sound, okay, emitting wavelength, we know wavelength. Wavelength coming from source of sound is 0.34 meters. All right. And for listen, we can say wavelength S. All right. We can use this symbol. And a petrol car is moving at constant, parked. Okay, first vehicle, so listener, parked. All right. And what else they said? A petrol car is moving at constant speed on the same road. Okay, listener is petrol car. Oh, okay, sorry. So source of sound, park. So it means Vs equals 0. All right. And then Vl is moving with constant velocity. For now, we are just getting all information from question. Just we know constant. How many meters per second? We don't know. Just we know constant. Okay. And then, but they said the driver of the petrol car here says sound with frequency 58 Z lower than. Okay. So frequency just getting lower. So FL is lower than FS. So what we understand from here, it means going away, right? Page 3. Okay. And then take the speed of sound. Okay, V, they said take V is 340 meters per second. 3 meters per second. What was our formula? FL is equal to V minus. Why I am saying minus? Because FL is less than Fs. It means going away. If it is going away, frequency getting less. So FVL, V plus Vs times Fs. Okay. This formula we are going to use for this question. And then we know wavelength. If you know wavelength, how can we get frequency? They don't ask, but we need frequency. Fs we need. How can we get Fs? V is equal to F times wavelength. So from this formula, we can get wavelength, but for now, we don't need. Okay, need to just carry on. Question 1.1. I told you understand question. Firstly, list source of sound, stationary. Listener coming with petrol car, and then going away. So going away with petrol car with constant velocity. We are getting from question everything. Just we wrote what we are getting from question. Let's continue now. Let's see, state the Doppler effect. Okay, definition for Doppler effect. We said 3 different options we have. Let's just clear all, but we'll come back. Okay, different definitions. You can write which one is easy for you. It is your job. Please try to memorize all of them. Please try to memorize one of them, let's say. One of them is fine. Let's continue. Let's see what they ask. Is the petrol car driving towards or away from? What we said, going away from, because FL smaller than Fs. Getting lower than, lower frequency you are feeling, lower frequency you are getting, Because of that, 1.2 answer is away from, because observed frequency lower. All right, because it is given here, observed frequency given. So far, question 1.1, they ask you define Doppler effect. That definition you should know. And then question 1.2, they ask you police car, just petrol car moving away or coming closer. Which one is away towards or away from? Which one? Answer is away from. Why? How we are getting that? Because frequency getting less. If frequency getting less, that's our case 3, we said. Case 3, going away. Done. Question, yeah, 2 marks, 2, 4 marks you have now. And then calculate the frequency of the sounds emitted by the alarm. So now we are going to calculate our frequency for source of sound. Remember we said S and L. Now V equals F times L. V is 340, speed of sound. And F we are going to calculate. Wavelength is given 3034. And then you are getting 1008 Z. Simple one, right? So we never start Doppler effect. It's coming from only this formula is the 1VFL formula we are using. If they're asking you frequency, wavelength is given, asking you frequency, you are using this formula. Or frequency is given, asking you wavelength, this formula we can use. Okay, let's see what else they are asking you. 1.4. Okay, the petrol car moves distance X meters in 10 seconds. Calculate the distance X. Okay, we are looking for distance. They like to combine topics, different topics in one question. Now let's see how we are going to calculate. Let's see our options. First of all, we need VL. Do you remember we said when we draw our diagram, what we know? Firstly, source of sound, stationary, Vs equals 0. How we know that? Parked, they said that alarm vehicle parked. So Vs is 0. What about VL, listener? VL, we don't know, we said we are going to calculate it, but we know it is constant. Okay, and we calculate our frequency, Fs is equal to 1000 in question 1.3. We calculated, and FL, they said 950. Why 950? Because they said 50 hertz lower than it was 1000 for coming from sound, and listener will get 950 lower frequency. Okay, and then we are looking for VL first. After that, when you get VL, you are using this formula from motion. Distance is equal to, because for constant speed, we can use this formula, V times delta T. For 10 seconds, time is given. In 10 seconds, we are looking for distance. Okay, so first of all, we are using our formula. As you see, it is plus minus, but we are going to use minus. You can write so formula from formula box straight. You can write like this, you will get 1 mark, or you can just write which one we are using. You can say FL equals V minus VL. Why minus? Because going away. Case 3. For case 3, we are using minus VL. So V plus VS. And Fs is our formula. Even like this, you can write. And you can get another mark, you can get 1 mark for this. Okay, from now, just let's write all givens. FL is 950, and 350, they said use for speed of sound 340, sorry, 340. 340 minus VL, and 340 plus 0, because VS equals 0, we know that, times by Fs. And you are getting velocity for petrol car, for listener, is 17 meters per second. And then you can use this formula, X equals V times delta T, 17 times 10, 170 meters. 6 marks like this. The other option you have, for this option, straight you are using, but I don't want this one. Is for V, you are just writing X over 10. straight. You are getting x from this equation. Okay, this is another option. If you like, you can use this way also. You are using this one, this formula, and you are writing v is equal to x over 10, x over t, and x over 10 you are writing. For VL, you are writing x over 10, and then only x unknown, so you are writing x for this one. This is another definition, another calculation, another method for you. So we have case 1, case 2, case 3. This question coming from case 3. Why? Because going away. How we understand it is going away? Because getting lower frequency. If they ask you about, okay, they don't ask, but I want to add that question, another one, 1.5. If you have wavelength S is equal to what we have, 0.34 meters. What about wavelength for listener? Just wavelength L, what is that? How can we calculate that one? What we are gonna do now? Wavelength is equal to V over FL, right? And then what we know, frequency, as you see, decreasing, wavelength must increase. Let's see, 340 over 950. Yes, 340 over 950, more than, because it was 340 over 1000, right? It was 340 over 1000, now 340 over 950, even we don't need to calculate. So as you see, just getting more, even we can calculate and show, just let's show exactly. All right, we calculate and we are getting this one, 0.36 meters. Other one, what was it? 0.34. As you see, for case 3, when source of sound going away from listener, or they are going away from each other, so frequency decreasing, getting lower, and wavelength increasing, getting longer. I hope it is okay. Case 3 question and question 1 question we have done. It will be add more questions. Okay, let's continue with next one. Let's clear all and continue with question 2. Okay, let's see what's going on now. Just let's see coming from what kind of questions they are asking. But please keep in your mind, we have 3 different cases. Case 1, stationary, FS, FL, frequency is same. But when you come to case 2, they are coming to each other, frequency increasing, wavelength decreasing. Case 3, what was it? They are going away from each other, frequency decreasing, wavelength increasing. Keep in your mind these things, and formula already you know. Okay, let's see what they ask now. A police car moving at a constant velocity with S. Okay, now source of sound is police car. Okay, that's right. This is our first point. Source of sound, Vs, constant, but we don't know how many meters per second, but moving. So we know that. Let's say constant. Okay. And listener, let's see. Pass as stationary listener. All right, we know VL equals 0. Just write it down, all right, on the question paper, on your writing this answer paper, you can write it down just like this, just to understand what's going on. So the graph below shows the change in frequency of the sound. Wow, they're asking some different questions. Just they're changing story, but we should know we have 2 points and 3 cases, all right. So constant velocity, source of sound, constant velocity, and listener, stationary, and graph shows, okay. That's it. State the Doppler effect in words. That is your job, I told you. As you say, again, they're asking every question, almost every question, they're asking the Doppler effect, Doppler effect, Doppler effect. It is our topic's name and definition, always they're asking. Okay, let's continue. This definition with you, please work on it. Please don't miss your mark because of definition. Please study, please just memorize all. Okay, change in frequency. And then as a result of relative motion between a source and observer, listener. As you see, underline here, if one is missing, you are losing your 1 mark, unfortunately. Okay, now they said, write down the frequency of sound detected by listener as the police car. I like this question because in this question we have case 2 and case 3. Closing, just coming to approach each other, coming to each other, or going away from each other. Now they said, write down the frequency of the sound detected by listener as the police car approached the listener. Okay, so which one? What do you think? It's coming closer. It is case 2. Our frequency, more or less? Our frequency, of course, more. 170 for FL when coming closer, because we don't know just frequency for police car, but we know when they are coming closer, getting more frequency. Because of that, when they approach, our answer is 178. From graph, you are choosing 170. Case 2. Okay, let's continue. What is next? They said, write down the frequency of sound detected by the listener as the police car moves away from the listener. If it is moving away from listener, what we know? Getting less frequency. So less frequency, where is it? 130. Our answer is 138Z. I hope it is getting better. You are understanding, you are getting it. Now, calculate the speed of the police car. Okay, we said, yes, police car is moving, but we don't know how many meters per second. We are going to calculate now. Take the speed of sound in air 340. Okay, let's write all givens. What we know. We know V is 340 meter per second. And this question is, it looks scarier because frequency is not given. Fs is not given. Okay, Fs, we don't know. Fs, but Fl we know. Fl, if it is coming closer, 178Z. If it is going away, Fl is equal to 138Z. So we are going to use these two information to get our Vs. Okay, it's velocity for police car, velocity of source of sound. All right, so let's see our solution now. Just let's clear all this side. So now we are using both of them. All right, 170 and 130. Both of them we are using, and then we are going to combine them. But because if you have two unknown, Vs and Fs, both of them we don't know. But what we said, for case 2, let's write, okay, let's use this side, case 2. For case 2, now what's going on? Just we said, okay, we don't know it's coming or going away. Just we said, if it is coming away, if it's coming to listener, source of sound is coming to listener. Now your Fs, we don't know, but you know Fl. Fl is equal to 178Z. Vs, we don't know. We are going to calculate. Both of them we don't know. Vl, we know it is 0. And V, we know V is equal to 340 meters per second. If coming together for case 2, we are writing this formula. Fl equals 170, and then V is 340, and formula is plus. You remember that, right? If for case 2, when they are coming closer, on top plus, and the other one is minus. So plus 0, and 340 minus Fs. And this formula we are writing, it's coming from case 3. Case 3 is here. For case 3, now what's going on? We said maybe police car is moving. If it is moving, what's going to happen? Fs, still we don't know. Vs, we don't know. And then what we know, V is equal to still 340, nothing changed. 340 meters per second. For listener side, for listener, Fl is equal to 130 now, because we know when it's going away, frequency getting less. So VL still 0, still stationary. Now, but formula is different. Remember that? Now 340 minus 0. As you see, for case 2, it was plus. For case 3, it is minus. So 340 minus 0, 340 plus 340 plus Vs. All right. So these two formula we are using, and then we are going to combine them to get our answer. How can we combine them? Your maths learners, huh? Your maths good. So I can write number 1 and number 2. You get just like this. 170 over 130 equals on top, maybe just like this. Okay, let me write. So Fs cancel each other. And on top we have 340. What is left? 340 over 340 minus Fs. And on top what we have? 340 plus Vs, sorry, instead Fs, Vs. Okay, 340 also cancel each other. Just one left here, one left there. And then, you know, in maths, it's going up. So 170 over 130 equals 340 plus Vs and 340 minus Vs. Okay, from now, cross multiplication you can make. It is a long process, but you can calculate it, right? So 170 times 340 minus Vs equals 130 times 340 plus Vs. From this point to there, how we are coming, you know that, right? In maths, just first one stay like this, 340 minus Vs, times other one just turning and coming up. You know that 340 plus Vs over 1, and then I can write like this. All right. So from now, you can just calculate, just use this way. I think we don't need to just carry on because I'm physics teacher, not maths. Okay, I'm your physics teacher, but I can teach maths also, it's fine. All right. So you are getting 45,33. Just calculating. Let me help you to finalize it. 170 times 340 minus 170 Vs is equal to 130 times 340 and plus 130 Vs. So 170 is coming, just coming other side, when this one is coming this side. And when you calculate, this side change to what we are getting, 300, right? 300 Vs, and this side 2 times 170 times 340, because same thing, I didn't calculate because of that I'm writing like that. And then you are getting Vs 45,33 meters per second, 2.3. So as you see, they are changing story. They are asking different questions, but end of the day, we have 3 cases, and 2 points. 2 points and 3 cases. We have source of sound, our first point, listener, our second point. Let's see anything else they're asking for question 2. Nothing. All right, question 3 now. Question 3. So, source of sound, stationary. Okay, Vs is stationary now. Let's use this side. Okay, what we have, stay S and L, and Vs equals 0. First of all, I'm just writing down for my 2 points what we have. And Vs is 0 because this is stationary police car, and alarm, just noise coming from police car now. Wavelength we know. Wavelength S is equal to 0.55. Okay, anything else about S? Nothing. Okay. Width, oh, yes, okay, it's just noise on, just we have noise. Police car now approach the station. Okay, approach now, it is given. We are busy with case 2. Okay, that's good. Case 2. If you are busy with case 2, we know our formula, right? Okay, so approach listener constant velocity. VL is constant. They don't tell you 0, all right? It is constant, but we don't know how many meters per second, but we know constant velocity. What else we know? Speed of sound, we use 345 now. V is 345 meters per second. And then case 2. Okay, let's see what they're asking. Firstly, Will the wavelength of sound be absorbed by listener? Okay, just different question. Check. Will the wavelength of the sound greater than, smaller than, equal to? Which one? So just, what we know, it is our case 2. For case 2, what's going on? Frequency increasing, right? So just wavelength, will the wavelength sound observed by listener coming closer? Wavelength increasing, we know that. Wavelength increasing when approached, because it's our case 2. Hey, this is our case 2. Frequency will increase, because when it's coming closer, we said frequency will increase, but wavelength will decrease. Wavelength getting shorter. So our answer is smaller than. All right. But if they ask you same question, but just put frequency here, what you are going to say? Greater than. I think it's okay. How they are going to change question? Maybe next time, just going away from listener, case 3. So that time, frequency will decrease, wavelength will increase. Just remember, for case 2, frequency increasing, wavelength decreasing. Because of that, smaller than. Question 3.1, answer is smaller than. Name the phenomenon. Okay, Doppler effect. We are busy with Doppler effect. Now they don't ask you state, or they don't ask you definition. They ask you what we are using here. So answer is Doppler effect. Let's write Doppler effect. This is our answer for 1 mark. And then calculate the frequency of sound. Okay. Now they're asking you calculate frequency of sound. But we don't have to use that long formula V plus VL. We can use only this formula. V is equal to F times wavelength. We know wavelength. We know V. We can calculate frequency. Okay, now let's show full answer. And then we can explain. We can carry on. So wavelength smaller than. Why? Because coming closer. When it is coming closer for 3.1, when it is coming closer, frequency getting more, wavelength getting less. And then we are using Doppler effect here. We are calculating frequency. They said calculate the frequency of sound. Okay, frequency of sound. But frequency of sound waves absorbed. So we are looking for FL. Okay, sorry, we said we don't need to use, but we are getting FS first by using simple formula, and then we are using long formula. All right, first of all, let's just write our S and L 2 points one more time. So S, what we know, Vs equals, Vs, what was it? Vs, is it given? Vs, 33, we are going to calculate Vs first. Okay, just let's check. All right, Vs is given. I was checking that one on top, but Vs is given here, 120 kilometer per hour. But we need in meter per second. From kilometer per hour to meter per second, we are using 120 over 3.6. How we are getting 3.6, you know, right? Kilometer to meter, 1,000 meters. And hour to second, we are using 60 times 60, 3,600. When you simplify this all, 1 over 3.6, and then you are getting 120 over 3.6, 33.33 meters per second. This is our Vs. Vs is given 33.33 meter per second. And then VL equals 0. And what else we know? V is 345. V already we know. V is equal to 345 meter per second. What about Vs? Do we know Vs? We are going to calculate with this question because we know wavelength. V is equal to F times wavelength. And then F is equal to Vs is here. We can just straight use it. Okay. Vs we know. And what else we need? Nothing else, right? So now we can calculate FL. But what formula? Plus or minus? You can straight write this formula, but when you start calculate, so you have to know what formula you are using for case 2. Coming closer. For case 2, FL is equal to V plus VL over V minus Vs. Also, you can see here, because VL is 0 straight, you can write V. And then V is 345. 345 minus 33.33 times Vs, and then you are getting FL. All right. So how we know they are asking you FL? Because they said calculate the frequency of sound wave absorbed by listener. So this is our FL. I hope it is clear. As you see, guys, still we carry on with 2 points and 3 cases. Case 1, case 2, case 3, even case 1 most we don't use, but case 2 and case 3 very important. Next one, now they said if the police car, 6.3, 3.3, let's say, if the police car moves away from listener, write down only just how will the increase 3.3, what was 3.3? FL. So frequency. How affect frequency? If police car is going away now, if police car going away, what we know? Frequency will decrease, of course. But if I ask same question about wavelength, what you are gonna say? Wavelength W, wavelength L, let's say. Wavelength L. So wavelength L will increase. I hope it is clear. If just going away, wavelength will increase, but frequency will decrease because now police car is going away. I hope it is clear. Question 3, done. Let's continue with next question. One more question. I think you are tired today, but I want to finish doing your Doppler effect. Doppler effect must be clear for you. Because of that, I want to give more examples. Okay, let's continue with question 4. This is our last question for today. This question straight answer is given. Okay, it's fine. So let's see. Now, a train approach a station at a constant speed. Okay, approaching, it means case 2. One more time, we are using case 2. Now we are using plus, let's say just plus. Okay, if you have case 2, let's use this side. Case 2, our S is here, our L is that side. They say train, police car, patrol car, whatever they are saying, it's fine. Just use your 2 points, SL, that's it. Source of sound and listener. And then direction, they're coming closer or going away. Just use case 1, 2, 3, done. So now VS is equal to 20 meters per second. And then station, okay, station cannot move. So VL equals 0. VL is equal to 0. And with frequency, it means FS equals 458 Hz. And observe standing on the platform, okay, because of that VL equals 0, we said already. And change in pitch train, okay, of course we'll get different. Name the phenomenon, okay, we are using Doppler effect. This is our question 4.1. Calculate the frequency of the sound that the observer hears while a train is approaching. Okay, now case 2 formula we are using one more time. FL is equal to V plus VL and V minus VS and FS. So 340 over 340 minus VS times FS. And then you are getting FL. I think it's okay, it's clear. If I ask you wavelengths, so how you are going to calculate? V over FL if you need, all right. So next question, how will the observed frequency change train pass? Okay, going away. So now one more time they are asking you same question, frequency. If train is going away, frequency, what's going to happen to frequency? Of course, will decrease. Answer is decreases. That's it. So we have done for today. I hope Doppler effect is good for you. I think it's okay for you. You get it, you understand. So see you next lesson with more examples. Doppler effect questions, more questions coming. So please come with me, stay with me. Continue next lesson. Have a nice day, everyone. See you next lesson.
Hi guys, another day, another topic. So day 5, we are going to answer questions with you from electrostatics. Question 1. I hope you did try already. You are going to get full mark. This question paper with 10 marks and then multiple choice questions with 2 marks. All right, let's see what they ask now. Two identical spheres R and S. All right, staying there. Spheres R. Okay, force is F. Okay, for electrostatic force between R and S is F. All right, so on sphere S, it means we can say F RS is F. Let's write here. You remember, if you have positive and negative charge, they attract each other. And then we can write here, so we have this side, let's write, let's draw and show. This one is given, F, R, S. So, and then this one is, as you know, F, S, R. It means because of R on S, force is given, this is SR. So FRS equals F. It is given in question. Okay, let's see what they ask. Two spheres are now contact each other, all right, and they are coming to original position. Okay, so magnitude of electrostatic force, that sphere R. Okay, because spheres are on, it means of FRS. They are asking you how many F we can say, F over 2, F, 2F, or 0. Which one is correct? So they are touching each other and separating. Or you see already, if they touch each other, they are going to get 0 charge, right? What's our final charge? Final charge formula, do you remember that? Final charge is equal to Q1 plus Q2. Q1 plus Q2 over 2. You know that? So we can say plus Q and minus Q over 2. And you are getting 0. If they have 0 charge, 0 coulombs, of course, they are going to make 0 force. That's it. So this is our answer. But if you get different charge, of course, you can compare with first one. But for now, we have 0 coulombs. Because of that, our answer is A. I hope it's clear. It was easy question, but we are answering with long process. It's fine. Just plus Q minus Q making 0, and then 0 charge making 0 force. That's it. Okay. And then next question. Let's see what they ask. Question 2. Two small charge spheres A and B. All right. And all charge given as you see. A with positive charge, B with negative charge. And the distance between A and B is given 0.4 meters. All units with coulombs. You remember, if you see another unit, please convert to coulomb. And if you see another unit for distance, we must convert to meters. And we have point M between A and B, midpoint. Yeah, that's important because otherwise we don't know between A and M. So A and M distance 0.2, M and B distance 0.2. Okay, now we know all given everything is sharp. So let's continue with state Coulomb's law in words. All right, Coulomb's law, last lesson was day 1, right? In day 1, they ask you electric field. Now, Coulomb's law. What is Coulomb's law? Let's see. Coulomb's law, magnitude of electrostatic force. Okay, just you can read all. Please just memorize all right? And this one is coming from, this one is coming from electrostatic force between two charges. K is Coulomb's constant, you know, 9 times 10 to the power of 9. 9 times 10 to the power of 9, of course, with unit. You can just get unit because you will get this constant number. And then Q1 times Q2 over R square. If you have two charges with Q1 and then Q2, distance between these two is R. So formula is K times Q1 times Q2 over R squared. This is our Coulomb's law. So what they said, magnitude of electrostatic force between charges is directly proportional to the product of the magnitude of the charges, product of charges, and inversely proportional to the square of distance. So from formula, you can get this one, this definition full coming from memorandum. So you can just memorize like this. If they ask you Coulomb's law, please write it down exactly the same. Otherwise, maybe you are going to lose your mark. Please be careful about that. So Coulomb's law, if you yes, Coulomb's law, should we remove anything? Just try to memorize all, all definitions, very important. So last lesson, electric field, now Coulomb's law. Let's continue with next question. Same circle, same diagram we are using, of course, A, B. Now, question 2.2. Calculate the net electric field at point M. So, calculate net electrostatic force, calculate net electric field, Coulomb's law, Ohm's law, this kind of things, very important for electrostatics. So, how we are going to calculate net electric field at point M? First of all, we should get, maybe we can carry on. Yeah, let's show solution also here. So, first of all, on point M, what electric field we have? We should just draw with direction. That is very important. So with direction, we are going to draw first. Okay, let's start with EA or E1, you can say, it's fine. So you have positive, right? So positive always repel to all objects. So if you have positive charge, electric field direction this way, just repel. Just remember that, all right? So electric field, this drawing is very bad. So electric field always repel. Okay, writing pad is making problem. So positive repel, just remember that. So A repel M. So if A repel M, direction of electric field for A, we can write EA this way to the right. Is it okay? And then what's next? For B, it is negative. Negative always attracts. Negative always attract all electrostatic force. So if it's attracting point M also. Okay, if it's attracting point M, so they have same direction. So maybe we can show like this. This is our EB. As you see, they have same direction. EA and EB, same direction. So we are going to calculate EA and calculate EB, and then we are adding them. That's it. So this is our solution. So let's calculate EA. This formula we know to calculate electric fields, K times Q. Electrostatic force, KQ1, Q2. But electric field only with one charge, KQ over R square. R is distance between point M and A, and then, so what's our distance? 0.2 meters, right? Because they said midpoint, yes, so 0.2 meters. And K is equal to 9 times 10 to the power of 9, and Q for A is positive 2 times 10 to the power of 5, negative 5, yes, and when you calculate 0.2, of course, distance 0.2 square, and then when you calculate 4,5 times 10 to the power of 10 to the power of 6 Newton times Coulomb power of negative 1 Newtons per Coulomb, also we can say. Electric field at M because of B. Now we are looking for EB. Electric field B on electric field on M because of charge B. K times Q over R squared, this is our formula. And another formula, QB is equal to 2QA. Why? Oh, okay. Because this is just 2 times 10 to the power of negative 5. This is 4 times 10 to the power. As you see, it is double. If it is double, of course, electric field also double. It's another solution for you guys. As you see, another solution. If you use this way, also it's okay. So EB is equal to K times Q over R squared, and then 9 times 10 to the power of 9 for Coulomb's law. coulombs constant, sorry, for coulombs constant. And then Q is equal to 4 times 10 to the power of negative 5, 0,2 r squared. But you cannot use this one if you have different distance. Please remember that. Not always working, all right. Now 0.2 meters. This is also 0.2 meters. It's okay, but otherwise you cannot use this one. So this is best way. Yeah? So 9 times 10 to the power of 6 electric field. After that, we are adding them. EA plus EB, and you are just adding them and getting your electric field. And they didn't tell you magnitude of electric field. They said just calculate electric field, net electric field, as you see. Because of that, we have to give direction also. As you see, direction is another mark. To get full mark, please write direction. So question 2.2 also done. I hope everything is fine. How many marks we have done for now? 10 marks, right? I think we have done for today. Let's just double check. Another option here, but it's same stuff. So you are gonna see now, directly just add. You know, Q, oh, wait. Oh, calculating electrostatic force using long way. Anyway, just option they are giving in memorandum. Let's explain. So F net, KQ1, Q2, you are calculating electrostatic force between them. When you get electrostatic force, F is equal to E times Q. We know that formula. And then you are just getting, but of course you should get charge also, charge for each, and then how we are getting that charge. So this is long way, people. And then you are using this option. Let me just double check how we are getting charge. No, just they cancel charge. Okay, F net is equal to E net times Q. So you are calculating F net first, and then writing E times Q, and then just Q charge cancel each other using this option. That's another way you can calculate. This is the long way. So because you're going to calculate electrostatic force between them, so it's fine. We don't need that. All right, so we have done for today. See you next lesson. You know what you are going to do. Please don't forget that. So we are going to carry on next lesson with electric circuit. Electric circuit, day 6. Day 6 next lesson. See you next lesson, everyone. Have a nice day.
Hi guys, physics time, action time. Please go to link, try first. Day 2, electric circuit questions. Question 1, 2 marks question. Let's see what they ask. We have a circuit and then variable resistor we have. They said in this circuit, variable resistance increased now. Okay, if you increase resistance, what's going to happen to your current and voltage? That's our question. Reading on a meter, reading on voltmeter, what's going to happen if you increase your resistance? That's our question. So what's our answer, people? You have your answers already. Please go to link, try first. Don't forget it. So answer is A. Why A? Let's explain. Because if resistance increase, current decrease. Do you know? And then if resistance increase, voltage also increase, because we know our Ohm's law. What was it? V equals I times R. As you see, voltage and resistance directly proportional to each other, but resistance and current, if one increase, other one decrease. Because of that, our answer is A. If resistance increase, current decrease, and then voltage increase. And then you have your 2 marks. Okay, that's our first question. As you know, every day we are trying to answer one multiple choice question and then one long question from different topics. So last lesson, day 1, it was electrostatics, and now electric circuits. Okay, let's continue with next one. Let's see our question 2. Today, let's see what they ask. All right, we have an electric circuit. So what we know, let's check. A battery with internal resistance, all right. Internal resistance we know, 0.5 ohms. And EMF, we don't know, all right. Connect to 3 resistors. Okay, we have 3 resistors, R1, R2, R3, 4 ohms, 25 ohms, 15 ohms, all right. Voltmeter and ammeter also we have. Okay, as you see, voltmeter connect to the battery directly. Okay, this is our circuit. And then question 2.1, another 2 marks. Today's paper, let's say paper, today's paper, 20 marks. Please try to get full mark. So define the term EMF of a battery. As you know, for each question, almost every question, they're asking just 1 or 2 definitions. So please try to memorize all definitions. So last definition, last lesson, what was it? What they asked? Do you remember electrostatics? They ask you 1 definition. Now asking another one. What is our definition? What they ask you now? Define the term EMF of a battery. Okay, other questions will come from this circuit, but for now, 2.1, define the term EMF of a battery. Answer is coming now. You can write any of these, so you can choose. Please write it down. Please make your list for all definitions. There's no another option, or you can print out, you can find for all topics, get your all definitions list and try to memorize. There's no another option for definitions. As you see, 2 marks. So please try to learn. So EMF definition is here. You can write it down. Work done by the battery to move a unit coulomb of charge across the circuits, or first one, which one is easy for you. You can choose any of these. This is our answer, people. Yes, let's continue. Now, question 2.2. Okay, this is our circuits, already we know. And reading on the voltmeter decreased by 1.5 volts when switch S is closed. Okay, as you see, our circuit switch is open now, but they said if switch S is closed, what's going on? Voltage on voltmeter decreased by 1.5 volts. And they're asking you why. Give a reason why the voltmeter reading decreases. So let's see our answer. This is 2 marks, another 2 marks. Because energy per coulomb of charge is converted to heat in the battery due to internal resistance. So if you use S is open, switch is open, internal resistance you don't need to use because there's no current. But when switch is closed, so you are getting here V lost.
V lost, what was the V lost? Do you remember that? V lost is equal to I times R. R means internal resistance. So V lost equals I times internal resistance. I, we don't know, we didn't calculate, it's fine. Just what we know, we have internal, so we are, because of we lost, total voltage decreases 1.5. As you see, they are giving you V lost. V lost is 1.5. But if they ask you, give a reason, you must say because of internal resistance, energy change to heat, convert to heat, just like a light bulb. So for also making resistance change to heat, you know. But this is battery. Battery also has resistance, internal resistance. Till grade 10, you didn't use internal resistance, but when you come to grade 11, so you are using internal resistance also. All right, so this is our answer for 2.2. Okay, time is going, let's continue. So now let's go to next question. 2.2 done. Now let's see what they ask. Okay, calculations coming. I like calculations. Calculate the following when switch S is closed. Okay, they gave you already V lost. It's fine, we can just keep it there. And then calculate the following when switch S is closed. Reading on the ammeter. Okay, they're asking you current. When you get current, so we lost, we have already, and then you can calculate other stuff also. But let's calculate what we know. We can calculate total resistance, right? So we have internal resistance R1, R2, R3, all we know. So you can get total resistance. And then what else we know? Internal resistance we know. So let's see our solution now. How can we get? Yes, using V lost, easy way, because if you calculate total resistance, still you cannot get current because you don't know total voltage, but you know V lost. So what we said, other question, V lost equals I times small r, we said, right? So you are using this formula now. I equals, in memorandum, just giving you Ohm's law formula, it's fine. But for R, you are using internal resistance. For V, you are using V lost. Current is equal to V lost over small r. All right. So when you check memo, they're just giving like this. But please remember, you are using V lost for voltage and then internal resistance for R. So that's our answer. Now we know current. So we know current, as you know, from positive to negative. So we can show direction of current like this. Current is equal to 3A. So now we can calculate our total voltage and then whatever you need, and then voltage for parallel. Just whatever they ask, you can calculate from now. It is easy because you know current. So you know current and you know resistance. All right, 2, 3, 1, 3 marks. I hope it's okay. We lost to get current, total current for circuit. So let's see what else they are asking. Total external resistance of the circuit. Okay, it is easy one because you know R1, R2, R3. What's our step 1? You are calculating parallel combination first, plus R1. So let's see. Yes, for parallel combination, you are calculating, as you see, 1 over R parallel. So formula is here. You know, we have different options for this question. 1 over R parallel is equal to 1 over R1 plus 1 over R2, 1 over 25, 1 over 15. And then, you know, you are going to calculate like this. And R parallel, you are getting 9,375. As you see, you don't round it off because it is not your final answer. This point is very important. Please remember, when you come to final answer, you can round it off. It's fine. But you must round it off, you know, for final answer. But before that, whatever you are having after comma, please try to use everything. All right. So R external is equal to R parallel plus R1, 9,375 plus 4, and then you are getting 13,375, and you round it off, and you are getting 13,38. That's our answer for 4 marks. As you see, first mark coming from formula, and then second mark coming from solution, getting for parallel. To get parallel combination, 2 marks. And then for solution, our external 1 mark, and final answer with correct units. Please don't forget to write units. Let's see option 2 now. Option 2 is similar, but using different formula. It's fine because that formula and other formula, option 1, similar. You can get this formula from there. And then same solution and done. So another question, EMF of the battery. They're asking you EMF of the battery. Now they're asking you voltage. So you know total resistance, but you must add internal one, don't forget. So you must just add internal one also. So EMF of battery, it's easy now because we have current, we have resistance. From Ohm's law, we know V is equal to I times R. So let's see our solution now. EMF is equal to I times R plus R. You remember, we shouldn't forget internal resistance. If you just calculate I times R, you're getting the external, not internal. It's not total EMF. All right, so I times R plus R. So you are getting, you calculate already external resistance plus internal resistance times by current 41,64 you are getting, and then your, as you say, you're just rounding off. Please don't forget to round after comma. For final answer we need only 2 digits, people. So 3 mark question, option 1 done. Option 2, another option. As you see, we are calculating the external by using I times R. I just R external resistance times by R current plus V internal. It means V lost. So we are V lost, V internal. You are adding. It's another option. It's the same thing. So maybe we can show. Okay, maybe we can show these two same thing. Option 1 and option 2. As you see, V external. What was the V external? V external is equal to I times R external plus V internal is equal to I times small r. And then you can write I times R plus small r. I times R plus small r. All right, as you see, first option and second option, same formula. So we can carry on with next question, 2.4. So 2.4, let's clear all. 2.4, a learner makes the following statement. Okay, the current through is R3 is larger than R2. Is this correct or not? Choose yes or no and explain the answer. So yes or no, 1 mark, and then 2 marks when you explain your answer. What they said, R3 and R2, they are asking you just R3 has larger current than R2. Okay, so let's see our answer now. Answer is yes. Why? Because for the same voltage potential difference, a larger current will produce a smaller resistance. Because in parallel, we have same. Answer is yes. Why? Because for same voltage, larger current for smaller resistance because of Ohm's law. You can say they have same voltage because of parallel combination. And then because of Ohm's law, current is equal to V over R. This is our first option. Or you can say V parallel is equal to, as you see, you can just calculate and show. That's another option. But you are going to say yes and you'll get your 1 mark. And you are going to calculate and show. That's another option, all from memorandum. And then another option you can calculate, V is same. If V is same, as you see, just you are calculating current for each, but it's supposed to I is equal to V over R. So this something is wrong here. It's fine, but you understand in parallel combination, they have same voltage. If they have same voltage, which one has less resistance getting more current? So this is our last question for today. They said the 4 ohms resistor is now removed from the circuit. Yes, they like this kind of questions. So they remove from circuit. How will this affect the EMF of the battery? Choose from increase, decrease, and remain the same. EMF of battery. If you remove 4 ohms from here, it means just open switch. So answer is remains the same because EMF of battery, even as is open, still same. So that's our answer for 1 mark. All right, we have done for today. I hope you get full mark. So see you next lesson, another day. Let's study with you. Please don't forget, you know what you are gonna do. See you next lesson, everyone. Have a nice day.
Hi everyone, welcome to our lesson, day 6 with electric circuit. As you know, we have 2 questions, one multiple choice and one normal long question. So please try first and then you can come and correct your answers. Question 1, we have this kind of circuit and then what they ask, which voltmeter will have the highest reading when switch S is closed? This is our question. So in parallel combination, what we know, if you have a current here coming this side, they are sharing current. If they are sharing current, of course, they are getting less current, less than this resistor, this less than that resistor. We are all right. Because of that, V1 has highest reading. We can continue with numbers if you want. We can just see. Let's just try. Let's say we have 5 or 10 anyway, just let's say 5A or another number you can use, 2.5A. They are sharing current. And then less current, less voltage because they have same resistance. I hope it is clear. It is fine. Let's continue with next question. Next question, let's see what they're asking. Wow, another circuit, long one. Okay, EMF is 12 volts. Internal resistance, we don't know. And then we don't know X. This resistance also, we don't know what power we know for that. Okay, when switch S is open, what is V1? Question 1, 2, 1, 1 is here. So we can say answer is 12 volts because V1 measures voltage for battery. Switch is open or closed, doesn't matter. Finally, V1, just you will get same result. So 12 volts. EMF 12 volts. When switch is open, EMF is 12 volts. Sorry, when switch is closed, V1 will be different because of the internal resistance we lost. Just we have lost also. So we lost. So V1 will be different. But for now, measures exactly same for EMF, 12 volts. All right, let's continue with next question. We are looking for V2. When switch is open, there is no current on 6 ohms. Because of that, V2 equals 0. Because we know from Ohm's law, voltage equals current times resistance. Ohm's law very important for this topic. V is equal to I times R, and you are getting 0 times 6 equals 0 volts. This is our answer for 212. Let's continue with next question. Let's see what they're asking now. Define the power. So we are looking for power, but now S is closed and the reading on the voltmeter is 1.2A. Main current is 1.2A and power for X 5,676. So they're asking you what is power. So some definitions important is that Ohm's law, just like Ohm's law, and power, current. Please try to remember, try to memorize all definitions. Power, the rate at which work is done or energy is expended, transfer, or transfer, you can say. Please try to memorize all. Now let's see what they ask. They're asking you resistance of resistor X. So we are looking for resistance for X. How many ohms? How can we calculate? We know power. If you know power, it is easy because power formula we know. Power formula P is equal to I times V. Power equals I times V, PIV. So for V, if you write from Ohm's law, for V, if you write I times R. So I times I, you are getting I square and then R. So we know power already, we know current already, so we can calculate resistance for X. So we are getting 4 ohms. That's it. Question 2.3. Another option we have from PIV, you can calculate voltage first. When you get voltage, you can use Ohm's law and calculate resistance for X, or you can use this formula to get R. How we are getting this P equals V square over R. So to get I square times R, we wrote I times R for V in first option. But now you are writing here, let's show V times, for current, you are writing V over R from Ohm's law. And then V times V, you are getting V square. So you can use this formula to get resistance. This is our another option. So you can use any option, which one is easy for you, of course. And next question, calculate total external resistance of the circuit. So we know already X is 4 ohms, and we know this too. First of all, we can add 2.4 and 6. We are adding these two, and then 8.4. 8.4 parallel to 6 ohms, and we are calculating parallel combination plus X. And then you are getting external resistance. Okay, so first of all, R2, they said 1 over R parallel equals 1 over R1 plus 1 over R2. This is our formula for parallel combination. 8.4, we are getting directly by adding 2.4 and 6. And you are calculating for parallel combination is 3.5 plus X. You are adding resistance X. It was 4, we calculate already. And then answer is 7.5 ohms. External resistance, 7.5 ohms we can get. And another option, also coming from 1 over R1, 1 over R2, you can write like this also. It's your another option. Next question, calculate the reading on voltmeter 2. We are looking for V2. If you need V2, of course, you need current for 6 ohms. Current for 6 ohms, we are going to calculate. So marking criteria, first of all, when you write formula or Ohm's law formula, 1 mark. And substitution to calculate V parallel, another mark. Substitution to calculate current for 6 ohms, another mark. And substitution to calculate V2 by using Ohm's law, VIR, or another formula is fine. You are getting another mark. Final answer with correct units, another mark. It is marking criteria. Now let's see our solution. First of all, parallel combination, you are calculating V parallel is equal to I times R, because parallel resistance we calculate already 1 over 6, 1 over 8 over 4. Do you remember? Just we done that. So you're getting parallel combination. When you get parallel combination resistance, divide by 8.4. Divide by 8.4, you are getting current for this side. Current for this side. This current, as you know, what current you have, it's going to carry on here with same current, and current will not use this. Why? It means you're getting current for 6 ohms. All right. So why divide by 8.4? Because these two, they are sharing voltage. Because of that, we should just use 8.4, not just 6. All right. So 1.4 times 3.5, V parallel we got. V parallel, maybe we can draw 1 voltmeter here for V parallel. So voltage for this one, for this 6 ohms, and then for 8 points, because this like this, or drawing all just together in one line, also same thing. So you're getting current. Now you have current is equal to 0.5 A. If you know current, if you know resistance, easy to get voltage. I hope you get our steps. First of all, parallel combination. You are calculating voltage by using R parallel and main current, and you are getting V parallel. When you get V parallel, divide by resistance for this branch, so you are getting resistance, and then you are getting current. When you get current times by resistance, you are getting your V2. step by step. You should try, of course. If you don't get it, please try to write your solution. I hope after that you are gonna get it. This one is just with highest level question. Okay, we can carry on with next question. Let's see what else they are asking. What is our next question? Okay, now they are telling you, okay, a length of wire, all right, with no resistance, is used to connect point P and Q. Okay, you are taking a conducting wire and then connecting P and Q. That's our question. What's gonna happen to your, what's question now? How will the reading on voltmeter V1 be affected? And choose from increase, decrease, or no effect. Explain your answer. So that's our question. So let's try to show. You are drawing, we are taking a conducting wire between P and Q. They're just using a conducting wire from P to Q. So if you do that, what's gonna happen? Your voltage on V1, which one asks V1? Yes, V1 how affected? That's our question. Increase, decrease, or which one they are asking? Yes, V1 decreases. Why? Because total resistance decreases, current increases. We know already if resistance decreases, current will increase, and then internal voltage V lost increases. V lost increases. Why? Because V lost, what was the V lost? I times R. If current increase, V lost also increase. And then external voltage decrease, another thing, just you can explain, and then you are getting your 4 marks for this question. Okay, because you remove some resistance. If you connect from P to Q, just some resistance getting off, and then total resistance decreases, and then affecting all your voltage. Total resistance decreases, and then your voltage also decreases. V1. This is our question 2 we have done for today. So let's see next lesson what we are going to learn. We are going to carry on with you.
Hi everyone, action time. Today what I'm gonna do with you, grade 12 physics 1-1. What is number 1? Past paper 1 and another one for question 1. So every video just we are gonna try to answer one question with you. Today question 1, multiple choice questions from 1.1 to 1.10. 20 marks total. Please try first, and then you can correct your answers, and then you can just count your mark. Please let me know on comment just what you are getting out of 20. So question 1.1, and from video link you can get PDF format of questions. Also you can try, or just you can pause video and you can try, but please try first. You are going to learn by trying. If you don't try, just see questions, watch video. No, doesn't help. Will help, but not 100%. To get full mark, please try first. All right, I think that's enough. So question 1.1. Let's start with forces. They're asking you about types of forces. Perpendicular force, okay. Perpendicular to surface. So which one of the following forces is defined by this statement? So which force? Normal force, resultant force, frictional force, or gravitational force? Which one always perpendicular? So this is our question 1.1. Answer is A. Why A? Because check all forces. Friction force, for example, just let's eliminate all forces. Let's start with friction force. Friction force, opposite direction of motion and parallel to surface, not perpendicular. Friction force is gone. And gravitation force always going down, so not always perpendicular to surface. As you see first diagram, force diagram, it is perpendicular to the surface, it's fine. But when you go to inclined system, just going down, not perpendicular with another angle. So gravitational force also gone. And then apply force or resultant force, it means F net, depends on apply force and other forces. So resultant force sometimes perpendicular, sometimes parallel, sometimes with another angle, so not always perpendicular, but normal force always perpendicular. You see this diagram, perpendicular surface. When you come this side, also perpendicular to surface. Our answer is A for question 1.1. You are getting your 2 marks. So let's continue with next one, question 1.2. Now you have 2 balls with mass m and 2m drop from same height, okay? And then when they strike the ground, which one of the following physical quantities will be same? Okay, so we are looking for which quantity is same for these 2 balls. Let's see. Answer is, okay, answer is still coming already. Let's explain first. So as you see, just formula, you remember formula, weight is equal to m times gravitational acceleration. As you see, weight depends on mass. If you just mass change, weight will be different. So if you have m, weight, let's say V1 is equal to mg, you can calculate with 9.8, it's fine. And then V2 is equal to 2mg. As you see, they are different, so weight will not be same. You have 2 objects with m and 2m, and from same height, just going to ground, let's say h for each, h, and we are looking for when they just touch the ground, strike the ground, so which one is same, which quantity is same. Velocity, as you see, velocity depends on acceleration. For now, you can say g times delta t because it's going down. So it is formula. And then g times delta t, because you see, it depends on gravitational acceleration. It's constant for Earth. And then time. As you see, you never see here mass. So velocity is okay, maybe that one. Okay, let's carry on. Momentum. Momentum depends on mass. As you see, if you have m, mv. If you have 2m, 2mv. So it is gone. And then kinetic energy depends on mass also. Kinetic energy, m and 2m. So getting different answer. Our answer is B, we can say. Our answer is B. Why? Because velocity, to get velocity, you don't need mass. Question 1.2, done. Another 2 marks, done. Let's continue with next one. This question about momentum. Okay, you have graph, momentum and time graph, and they're asking you, okay, which one following time interval, right? Measured in seconds, okay. Magnitude of net force acting on the object is greatest. Okay, we are looking for force. Which one? Between 0 and 1 second, or 1 to 2 seconds, 2 to 3, 3 to 4. Which one getting higher, just which one greatest force? That's our question. So let's see our formula first. F net times delta t is equal to delta p. We know that. And from that formula, we can write force formula. Force equals delta p over delta t. And then we can calculate for each. So from 0 to 1, how can we get? Let's say F1. Okay, F1 is equal to F1 delta P for 1 second. What you have? 20. So 20 minus 0, because for 0 you have 0 here. These 2 points we are using. And time 1 minus 0. And then you are getting 20 newtons. This is our first one, F1. Okay, F1, using that, F1, let's say F1 is equal to 20 newtons from 0 to 10. We are looking for greatest one. So let's calculate next one, 1 to 2. F2, let's say, from 1 to 2 seconds. F2 is equal to delta P over delta T. So what we have now, for 2 seconds, we have 10, as you see. 10 minus what we have, 20, and 2 minus 1, and then you are getting 10 newtons. Negative means just opposite direction. It's fine. Directly you can say 10 newtons because we are looking for magnitude of net force. We are not busy with directions. So we have 10 newtons, but we are looking for greatest one. B already gone because 20 is more. And then 2 to 3, one more time, F3, let's say, F3 is equal to, what we have for 3 seconds? -10 minus what we have? -10 over 3 minus 2. You are getting also 20 newtons. These two same. Let's check from 3 to 4. I think answer is here. 3 to 4. F4 we are looking for now. For 4 seconds, what we have? 20. P2, P final minus P initial, you can say. Okay, let's explain this also. Delta P, it means P final minus P initial. And T final minus T initial. P final equals for 4 seconds, 20 minus -10. We are using like that because P initial is -20. And then T final 4 minus 3 and getting 30 newtons. Yes. So from 3 to 4, we can say our answer is D. All right. So we carry on. Let's see correct answer. We just calculate all. Maybe you don't need to calculate. You can just say, as you see, you can just use this angle. As you see, just increase. So what formula always, just to make sure you can use that way. All right, 1.3 done. Another 2 marks done. Next question. This one, work and energy. A ball is dropped from a highest flow. Okay. The ball makes an elastic collision with flow at time t0. Okay. You have a ball. Let's draw and let's try to explain. You have a ball and it is coming down and hit the ball and flow, just coming back. Okay, this one is happening now. Let's see what they ask. Which one of the following graphs shows how the total mechanical energy? Okay, total mechanical energy graph. Total mechanical energy. So if object is going down, what kind of energy transfer happening? Potential energy, E potential, transfer to E kinetic, right? Let's say we have 100 joules potential energy, and then kinetic energy, let's say, because there's a drop, so kinetic energy is equal to 0 from initial. And then final kinetic energy, let's say 100 joules transfer to all kinetic potential is equal to 0. Height is 0, so because of mgh, so you can say 0. But we are busy with mechanical energy. What was the mechanical energy? Mechanical energy is total energy. For now, we have potential plus kinetic. So potential energy plus kinetic energy giving you mechanical energy is still same. 0 plus 100, mechanical energy for initial, EM1 equals 100 joules. We are just using numbers, but it's fine just to understand. K plus EP is equal to 100 joules. As you see, from 0 to T0, first time when just hit the ground, and then from T0 to final one, still mechanical energy is same. So mechanical energy is constant. All right. So, and then we can see also conservation of mechanical energy definition. Sometimes they're asking you that conservation of mechanical energy states the total mechanical energy in an isolated system remains constant. Because of that, our answer is B. Question 1.4 done. Let's continue with next question. Let's see what is the next question. This question about spectrum. 2 spectrum diagrams below. As you see, diagram 1, diagram 2, from blue to red. Diagram 2, let's see what which one of the following can be deducted from spectra above. So the star is moving towards the Earth. If it is coming closer, you don't see like that. Star is at rest. If it is at rest, you're supposed to see same lines. Start moving away from Earth. Yes, this is correct. And both stars and Earth move towards each other. No, they don't towards each other. They are not coming to each other. Just they are going away from each other. When you go to that topic, we can just get more details. For now, our answer is C for 1.5. Let's continue with next question. Electrostatics. Okay, so question 1, too many different topics. Electrostatics now. The diagram below shows the field lines, okay, for electric field, and P and Q with different charge. asking you which one of the combinations below correctly shows the polarity of P and Q, positive or negative for P and Q. So we have to remember direction of electric field. Direction of electric field from positive to negative. Direction of electric field from positive to negative. Because of that, our answer is D. Why? Because P is positive. How we know? Because direction of electric field from positive to negative. Q is negative. Let's check options. P negative, no. And then B, option B says P negative, no. Option C says P positive, yes. But Q also positive, no. But positive for P and negative for Q. Just we should remember direction of magnetic field from positive to negative. Sometimes they're asking you draw direction of magnetic field lines. Sometimes just giving you as you just like this question. They are going to ask you polarity. This is our question 1.6. Answer is D. All right, let's continue with next question. Okay, another electrostatics question. Two identical spheres P and Q, okay, carrying charges positive Q and negative Q. Okay, let's draw our diagram. So we have positive Q, another one negative 2Q, and this one is P object and object Q. Okay, electrostatic force between these two, how can we calculate? Using Coulomb's law to calculate. So they have same magnitude of electrostatic force using same formula. For example, let's say F P Q. Because of P, just let's say this is F P Q, and then this is F Q P. What's the difference between these two? Only directions. Okay, because using same formula, K Q1 times Q2 over R square, or you can say QP, QQ is fine. K is constant number. Q1 is equal to plus Q. Q2 is equal to negative Q, but we don't have to just use 2Q. Negative, we don't need to use. Distance still same. As you see, distance between these two, they don't touch, still same. And you are getting K to Q square over R square. As you see, this is FPQ. When you want to calculate FQP, you are going to use exactly same formula. Q1 times Q2 over R square, and then you carry on K times Q1 is Q, Q2 is equal to 2Q, and R square, as you see, K times 2Q square over R square. As you see, you are getting same answer. If you want, you can give some numbers. For example, for each Q5 or 1, you can just calculate it if you want. But just know, if you have, even you don't need to calculate, but just to understand, I'm calculating it. So if you have two charges, if you don't touch magnitude of charges, if you don't touch distance, so you have same force, same electrostatic force between these two. Now we can see answer. As you see, our answer is B, because using Coulomb's law, Coulomb's formula, and getting same force. All right, now we are going to electric circuit. Identical, okay, let's see, resistors identical are all right. And internal resistance, we don't have, okay. Which voltmeter will have the highest reading when switch S is closed? So that's our question. What do you think? I think you have done already because we said cry first. So our answer is V1. Why our answer is V1? Let's explain. Guys, first of all, when switch is closed, they said, okay, switch is closed now. First of all, we know V2, V3, V4, same voltage, because in parallel, we have same voltage. And then, if we say we have current here, we can carry on with numbers or just say IV, using Ohm's law, of course. If you have R is equal to V over I, so I is equal to V over R. So, we are looking for V voltage, so we can say V is equal to I times R. So whatever you need, you can use. From Ohm's law, you can write 3 different formula. Now we are using voltage. So let's say, let's give numbers, or let's start with I. Okay, if you have I, what's your V1? V1 is equal to I times R. I think it's okay. But when you carry on with your conductor on the circuit, just carry on and come this side. When you come here, current sharing by these 2 resistors. So you have I over 2, and this side we have I over 2. So V2 is equal to I over 2 times R. As you see, half of V1. And V3 also same. V3 is equal to I over 2 times R. As you see, it is half. So you can just see from here. V4, when you come to V4, you have, yes, you have this way. Let's use current. When you just calculate this 2R, R over 2, you are getting right, because 1 over R plus 1 over R, 1 over R parallel, even you don't need this calculation, it's fine. Okay, 2 over R, and then R parallel is equal to R over 2. Now you have resistance, this combination, R over 2. When you calculate V4, I times R over 2. As you see, same as V2, V3, V4. So V2, V3, and V4, they are same, but V1 is higher than that. If you want to use numbers, if you are not okay with this, you can carry on with numbers. So let's say we have 10A, and the resistance, let's say, let's say 10 ohms. Okay, 10 method. Let's use 10. So you have 10 over 2 times 10, getting 50 volts. And then 10 times 10, 100 volts. As you see, 100 volts, 50 volts, 50 volts, 50 volts, you can calculate. Okay, too many things. But they are sharing current. What we should remember? We should remember just they are sharing current, parallel combinations, sharing current. That one is your keyword. Just getting answer from that. Answer is A, V1. Next one. Which one of the following electrical machines is electrical energy converted to mechanical energy? Electrical to mechanical energy. So generator, first option, AC generator. Guys, generator converts energy from mechanical to electrical, because generator, you are trying to make energy, you are trying to just get energy. So another one, DC generator. DC generator also making mechanical to electrical energy, and then AC dynamo, just that one. Not our answer, and our answer is what? DC motor. Our answer is D. Motor, just electrical, just with that machine. DC motor convert electrical energy to mechanical energy. 1.9, answer is D. Easy question, huh? And next one. Which one of the following combinations correctly links an emission spectrum and absorption spectrum? Energy transition, electrons in atom. Okay, just we should remember something about this question. After that, easy for you. So energy levels you have, let's say E1 and E2. And then you have electron here for E1, let's say from here, firstly it's going up, for example, electron just going up. If it is going up from low to high energy level, from low to high energy level, what's going on? First of all, just we should remember that. All right, maybe we can just show our energy levels and diagram, and then you're gonna get it. What's going on? Let's continue. This is our question. Emission spectrum, absorption. Let's see our diagram. Yes, energy levels here. So from lower to higher energy level, absorption as you see, and then from high to low energy level, just emission. Because of that, our answer is from high to low energy level, emission spectrum, and from low to high energy level, absorption. So that is our answer D. All right, 20 marks. Please let me know what you get out of 20. So that's our first video about this past paper. So we're going to carry on with question 2 next lesson. Thanks. See you next lesson. I hope we'll help you. Good luck for your exam. So please let me know if you need any topic, and then we can just make another video for you. See you next lesson, everyone. Have a nice day. Hi, everyone. Welcome back. We are going to continue with our grade 12 physics final exam. Yes, final exam is coming, so we must answer our questions. What I'm going to ask you, like always, please try first. I will give you 30 seconds for each question. I will try to read some questions, or you can read and you can try. 30 seconds for you. Today, we are going to answer some multiple choice questions. 10 questions we are answering with you from 1.1 to 1.10. Question 1 is coming now. Question 1, 1.1. An object is moving to the left at constant velocity when a force Fx on it. Magnitude of frictional force acting on the object is 0, smaller than applied force, equal to F, larger than F. So your 30 seconds starts now. Please try. Always we should try first. An object is moving to the left at constant velocity. That point is important. Your time is getting 0. Now. Yes, 3, 2, and 1. Time is up. So, time's up. We will continue now. But if you need extra time, please stop me and carry on. So, how can you answer this question? We are looking for frictional force. But what we know object is moving at constant velocity. What does it mean, constant velocity? Constant velocity means acceleration equals 0. If acceleration is 0, and if I write Newton's second law, F net equals m times a. From Newton's second law, I'm going back to Newton's first law. F net equals 0. Friction force. What we know about friction force? Friction force always opposite direction of motion. So we have some important points. To get good mark, we have some important points. One important point for friction force, always opposite direction of motion. This object is going to the left direction of motion this way. So friction force going this way. Friction force, opposite direction of motion. And then we know F net equals 0. We are using Newton's first law. Why? Because object is moving with constant velocity. You can say this question is easy. Why you are keeping us for one question so long? We are trying to give you some important points. Because when you go to another question, they're going to change just something, small thing, but they're going to ask you small, that plus minus same stuff. F net equals 0. What's our F net? Always direction of motion, we are choosing positive. So F first. F minus, I'm writing F net now. F minus friction force equals 0. And then I can take friction force other side. F apply, F equals friction force. So our answer is equal to F. Done. What we know, at constant velocity, F net equals 0 because our acceleration is 0. Friction force, always opposite direction of motion. And you are writing Newton's second law or first law. If you use second law, you are going to write acceleration is 0, and then you are coming to Newton's first law straight. Or you can use from initial, just you can use Newton's first law, and you can say F minus F equals 0 and calculate. Done. Question 1.1 done. Okay, let's continue with next one. Answer is C. Answer is showing. After 30 seconds, maybe I can show answer straight. So next question is coming now. Question 1.2. Yes, let's start. Let's give you 30 seconds. This is our question. Apply force acting on X. And then they're asking you magnitude of the force on block Y by block X. So you are looking for force between X and Y. Options here. Please try. If you need extra time, you know what you're gonna do. Please try first. Yes, time is up. So how we are gonna calculate force on Y? Force on Y, we are gonna calculate now. So let's continue. First of all, we are using Newton's second law. F net equals, but what we know about this motion, let's check. F is applied, all right. Smooth surface, there's no friction force, okay. And if no friction, if apply force acting this way, so of course object is moving this way. And then accelerating, of course, because there is no friction force, there is no another force, of course object will accelerate and going to the right. So if I write my Newton's second law, F net equals m times a. This is our Newton's second law. But mass, not this mass, don't misunderstand, this is formula, just as m times a. But what mass we have? Total mass, m plus m. F net equals m mass of x plus mass of y together times a. For this system, if you write Newton's second law for this system, you are writing like this. So, and then F net, what we have, apply force. Yes, we can write straight. We can write that one here. Let's write our apply force straight. Let's say F apply is equal to m plus m times a. I think this point is okay. And let's go to this way. We are looking for F, X, Y. So force on object Y by block X. On block Y by X. So Fxy, we are just calling like that. So Fxy equals, this force is equal to m times a. Why? Because this force pushing only object Y, and mass of object Y is m. So I'm looking for Fxy. But as you see, I have two equations. If I take this A alone with F, so can I write acceleration equals F over m plus m? All right. So we are just using this A here and then coming this side. So Fxy equals m times F over m plus m. So answer is Fxy equals mf, apply force, over m plus m. I think it's okay. Our answer is D. We said straight, we are going to show, but we couldn't do that. So first of all, you are writing Newton's second law for full system, and you are writing Newton's second law just for Y. And then you are calculating acceleration from first equation, and then taking that acceleration, putting on Fxy, and you calculate your Fxy. I hope it is okay. Let's continue with next question. Answer is D. Now another question for you. So question 1.3. This one, let's see what they said. We have 4 planets here. 1, 2, 3, 4, 4. Yes, number 4. And then first mass m reduces r. Second one is mr. Other one is 4mr, 2r, 16m, 2r. And they're asking you which planet, so which one they have equal gravitational acceleration. So gravitational acceleration, we have a formula. So formula box, in formula box you can have it, but I can write it here for you. So G equals, let me write here, G equals capital G times M1 times M2 over R square. So we are using this one, but, oh, sorry, not M1, M2, M1, M2 for all fours, just M. Okay. G times M over R square. This is formula for gravitational force. This is constant number, G. You can get it in formula box. And mass is mass of planet. R is radius of planet. So you are using this formula for each, and then you are going to say which one equal. 1, 3, 4 all equal, or 2, 3, 4 equal, or 1 and 2 equal, and 3 and 4 equal. Let's see. So you have time, 30 seconds, starting now. Let's give your 30 seconds. Yes, please try. Just write formula, gravitational acceleration formula, and getting your answer. The simple one. This question is okay. Other harder questions waiting for you? Other topics? Today we'll try to answer all topics, all physics topics, grade 12 physics topics, all multiple choice questions for you. Okay, time's up. Let's start. So, first of all, if you use, okay, let's use different colors now. First one, G equals formula, capital G, M over R square. This is our first one. First planet gravitational acceleration. Second one, G equals G, capital G times 4M, because mass of, and then R squared. So this is second one. Can anything simplify? Nothing, all right. So this is our number 2 already here, okay. And next one, G is equal to capital G times 4M over 2R squared. So 2R squared is equal to 4R squared. So 2R squared equals 4R squared. So, and then 4 cancel each other. What we are getting, G times M over R squared, as you see, is equal to number 1. So 1 and 3, they are equal. Let's continue with next one. Next one is G equals capital G times 16M over also 2R. So 2R squared is equal to 4R squared. So you can write 4R, and 16 over 4 is equal to 4. G times 4M over R squared. This one looks like number 2. As you see, it is here. Exactly the same. Let's draw here. So 2 and 4 also equal. Let's check. 1 and 3 equal. 2 and 4 equal. 1 and 3 and 2 and 4. So this is our answer, gravitational force. Let's continue with next question. I hope everything is clear so far. 3 questions we have done for you, but still we have 7 questions. Let's continue with next one. So answer is D. Yes, 1.4, projectile motion. This is easy one. They're asking you maximum momentum. Just we are taking object, going up from B to C and then coming down. Which position object has? Object just has maximum velocity. This object getting maximum momentum. Yes, velocity also important, but momentum. They're asking you momentum. Let's give your time. Okay, this time to try. I must keep quiet. Time. So you are looking for maximum momentum. Which point has maximum momentum? Please try. 1.4. This is about projectile motion and momentum together. So last 1 second. Yes, time is up. Our answer is, now let's show, answer is A. Why A? Because at point A you have maximum velocity. What was the formula for momentum? Momentum is equal to mass times velocity. If your velocity is maximum, Your momentum also maximum. So this is our answer point A, because let's check. Let's say this is our initial velocity. Even you can give some numbers. Let's say 5 meters per second. If you start with 5 meters per second, then object is going to highest point, velocity is 0. Change to 0 because highest, and then it's coming down. It's more than 5, maybe 6, 7, but more than 5. Let's say 7 meters per second. And then it is increasing when it's coming here, maybe 10 meters per second. It depends on time, of course, but just giving numbers just to see what's going on. Firstly, velocity decreasing from D to C, and then increasing from C to B, and then B to A also increasing, and the maximum velocity at point A, and then maximum momentum at point A also. If they ask you minimum momentum, point C. If they ask you maximum potential energy, what you are going to say? Maximum potential energy. Maybe next time they are going to ask you that question, who knows? Just they will ask you maximum potential energy at point C. You can say it is 0, but how it's maximum? Because potential energy depends on height. M times G times H. You don't need velocity for potential energy. I hope it's clear. So if they ask you maximum potential energy, you are just talking about height. So maximum height at point C. And the minimum potential energy at point A. Minimum potential energy. I'm shouting, sorry. Just like in the classroom. So point A, potential energy is highest potential energy at point C, minimum potential energy at point A, but maximum momentum at point A. Answer is A. Let's continue with next question. Question 1.5. Okay. If the momentum of an object is double, then kinetic energy of object is what? Your time starts now. You must just remember momentum and kinetic energy. Momentum and kinetic energy. So definition between momentum and kinetic energy we should remember. Momentum formula and kinetic energy formula. Your time, yeah, you have time, last 5 seconds. Of course, if you need extra time, you can carry on, you can stop video and you can try. So time's up. So let's continue. Momentum double. If the momentum of an object is double, so momentum equals m times v, and then kinetic energy equals 1/2 times m times v squared. So if you double momentum, in this question, this past paper, when we check, they are giving you 2 options, B or D. If you change velocity, if you want to make double momentum, you must make double velocity. So if you make double velocity, it's going to be 2v. Okay, 2v, and then 2p is equal to m times 2v. So you are making double momentum, yes. And just write 2v here. So 1/2 times, not equal, 1/2 times m times 2v squared, and then 1/2 times m times 4v squared. So you can take 4 front, 4 times 1/2 times m times v squared. So we are making 4 times greater. This is our answer. But another option, they said double. Maybe they think change mass, just to make it double. Maybe you can just change mass, not velocity, making double, just changing mass, because they didn't say that clean. Just to make it double momentum, you can make 2p is equal to 2mv, making double for mass. And if you make 2m here, so 1/2 times 2m times v squared. So you have only 2m, no square here. Just you can take 2 front, 1/2 times m times v squared. Now double. But I choose this one. This is best one, because objects changing mass, it means you are adding some extra stuff, extra particles. So changing objects. So I don't know about that one. But the answer is D. Let's say. Let's continue. So This is our question 1.5. Next question, work, energy, and power question. Which one is correct? We have 1, 2, 3 options. Which one is correct? Only one, 1 and 2, 2 only, 1, 2, 3. Which one? Your time starts now. Please read question and try. You have 20, yeah, time is going. Let's continue. Question 1.6. Work is done on an object only when a force. Okay, let's check. Yes, time is going. So 3, 2, 1, and time's up. So let's continue. All right. Work is done on an object only when a force is placed on object same direction. Just object is placed the object in the direction of force. No, even different direction they are having, because just remember friction force, friction also making work, but opposite direction, negative direction, because you have on just object and you have apply force and friction force. Friction also doing doing work, but negative. So this option is not correct. Total mechanical energy is conserved only the absence of non-conservative force. Yes, without, because total mechanical energy is same if you don't have friction force. All right, so this one is correct. And the work done on an object by a net force is equal to the kinetic energy of the object. It looks correct, but forgetting about change here. Change in kinetic energy, change of kinetic energy. This is work energy theorem. So too many times they're asking this question. Work energy theorem is something like this, but we should say change in kinetic energy. Because of that, this option also not correct. Our answer is only 2. 2 only. Option is C. C is correct answer. So let's continue with next question. 1.7 is coming now. Let's give your 30 seconds now. This is Doppler effect, all about frequency, wavelength, velocity. A car is coming closer to listener, stationary listener, and asking you which one will not change. Which of the following properties of the sound waves heard by the listener will not change? Time is over. Okay, so what they ask you now, let's check question. A car is coming with noise, okay, with constant velocity, and then as car moves away, yeah, moves away, okay, going away, sorry, not coming, going away. So for this kind of question, for Doppler effect, we are using 2 points. First point, source of sound. Second one, listener. And then VL, we are saying velocity of listener is 0 for this one. And velocity of sound is equal to, we don't know, but that is going constant. And then we have Fs, we have Fl, and which of the following properties sound waves heard by? Okay, not real one. Which one just detecting from that? Which one heard by listener will not change. So we have a formula. Fl equals V, speed of sound, plus minus VL and V plus minus Vs times Fs. This is our Doppler effect formula to calculate frequency. Why we are saying plus minus? This is general formula. Plus when it is coming closer, minus when it's going away. Now it is going away, so we are going to use this formula. Let's check. We are using Fl equals V minus VL and V plus Vs. VL, velocity of listener, Vs is velocity of source, and V, speed of sound, and times Fs. So which one will not change? Velocity, V listener already constant 0. Okay, by the listener will not change. So velocity will not change. Let's say that because as you see velocity, you are not calculating velocity, you are calculating frequency. So frequency getting different. If frequency getting different, option B is gone, option C is gone, option D is gone, because all of them, including velocity. All right, sorry, frequency. Oh, just all of them, including frequency. Because of that, if frequency change, wavelength also change. If frequency decreasing, wavelength increasing, you know that. So Doppler effect, object is going away. For Doppler effect, we remember our formula. This is our general formula. If it is going away, minus plus. So if it is coming closer, plus minus. Remember that. So let's continue with next one. Next question is 1.8. 1.8. This one is electrostatic question. Let's check question what they ask, and then we can give your 30 seconds. First of all, okay, 3 charged objects. We have P, Q, and R. Okay, on the system we see that Q is positively charged, plus Q, okay. So sphere Q and R distance from each other with D, all right. And R is negative Q, okay. The magnitude of charge on sphere P is 9 times greater than that on sphere Q. Okay, it means P, QP is equal to 9Q. But we don't know positive or negative. All right, we'll decide about that because they said 9 times greater than that, but they didn't say negative or positive. Negative and positive, we'll work on it and we'll get it. Okay, let's see what they ask. For now, I think everything's okay. Which one of the following combinations of vectors will cause the net electrostatic force on object Q to be 0? Yes. Okay, we know charge of Q and R, so it means we can calculate force here. Let's say it is attracting each other, so just attracting force F R Q this way. And then if you want to get sorry, I didn't give your time. Okay, sorry. Okay, your 30 seconds starts now. Forget about FRQ. Let me clear all. Yes, your time starts now. We are looking for, okay, we are looking for distance between P and Q and charge for P, sphere P. Please try. Yes, time is, yes, time's up. Okay, so now I can explain. So we have force on Q, name is F R Q, and we have to draw this way because we know F net equals 0 on Q. So F P Q this way. So if it is this way, if it's attracting Q, it is positive. What we know, positive and negative. So positive is gone. So we have negative charge. Attracting negative charge because attracting Q. How we know attracting? Because we are trying to get 0 charge. Okay, and what else we know? They are equal. So if they are equal, I'm going to use our formula. So K times Q charge of R times charge of Q and D square. How I am writing this? Because I know electrostatic force from Coulomb's law. Formula is K times Q1 times Q2 over R square or D square. It's fine, distance between them. By using that, I'm just writing this formula. So we can say K times Q square over D square, right? We can just write like this. And same stuff, same thing here. I'm just writing formula for FPQ. FPQ is equal to K times charge of P is 9Q. Okay, 9. Let's write 9, not Q. 9. Now I can write Q 9q, and charge of q is q, and it looks like 9 now, sorry, and x square. So we know these two, they are equal. Okay, let's write here. K times, I'm writing FPQ first. K 9q square over x square. I'm writing FPQ now equals FRQ. FRQ, what's that? K times q square over d square. So now I can just cancel q square here and k cancel each other. What is left? 9 over x square equals d 1 over d square, sorry, 1 over d square left, so 1 on top left, 1 over d square. So x square equals 9d square, and then square root each, x equals 3d. X equals 3d we are getting. So it is negative and 3d. Positive and 4.5d? No. Positive and 3d? No. Negative and 4.5d? No. Negative and 3d? Yes. Answer is D. I hope it is clear. So we must just continue step by step using Coulomb's law and getting answer. So let's continue with next one. 1.9 is question. This tricky question. It looks easy, but try. You have 30 seconds for this question. Electric circuit question. A voltmeter has a 0 reading if it is connected between 2 points. FG, EG, GH, DH, oh sorry, ED, FG, FH, or GH. Which one? Please try. You have 1 second. If you need extra time, you know what you are gonna do. So question 1.9. Which voltmeter, which point, if I use my voltmeter, you know voltmeter always connect in parallel. So let's use this voltmeter. Yes, our voltmeter is coming now. This is our voltmeter. I'm gonna take this voltmeter and connect to ED, FG, FH, GH. Which one is giving you 0? Let's try. ED first. Okay, I'm gonna use point E, and we can make it longer conductors, it's fine, between E and D. If I do this, which components? I'm just measuring voltage for which component. As you see, voltage for battery, voltage for cell, let's say, because it is single, voltage for cell. So because of that, you cannot get 0. Is it clear? So ED is gone. You cannot get 0 for that. Because you are measuring just like this one. You know, voltmeter connecting here. What you are going to measure? You are going to measure voltage for battery, voltage for cell. Yes, let's say cell. Because battery, 2 or more cells coming together. I was teaching grade 8, 9. Yeah, just voltage for the cell. It's the same thing, because this point here or there, it's the same thing, because there's nothing, no component, or point this one or coming to D, it's the same thing. All right, because of that, ED is not getting 0. We are looking for 0 voltage. We did try with ED, but it is not. And then FG. Okay, let's try FG now. Okay, from F to G, I'm just adding voltmeter. It looks tricky, but okay, FG. FG also not giving 0 because F is here. Just carry on from F. As you see, there's no component, nothing. Just like point E, it's coming here. It's this point. And then when you come this side, carry on, come, this side, come. Finally, you just coming here. As you see, you have cell here. One more time. It is same thing, just like using your voltmeter on the cell or using like this long way. Okay, you can say, why not FG here? You are measuring, it's the same thing, all right? So you are not, because you have switch here. If you don't have switch, everything will be different, but now you have open switch. Yeah, let's say open switch. So you are getting, yeah, let's say you are not getting 0. You are getting voltage for cell. FG also gone. Let's continue with next one. I'm sure you know answer now. FG. Okay, if you take FG, voltmeter for FG, I'm drawing voltmeter for FG. For FG, if I start from G, carry on. Okay, you stuck here. You cannot continue anymore. You cannot go to battery now. So just you should stop here. And when you come this side, you are going this way, but you have incomplete circuit. So you cannot continue that way because of this open switch. But what component you have between F and G? Component R. And what is current for the system? I. So I equals 0. Why? Because I know we have open switch. So V equals 0 times R, and then you are getting 0 voltage. I hope it's clear. So because you are just measuring voltage on R, current is 0. Because of that, voltage also 0. Let's continue with next one, GH. Now, GH, you just check for GH voltmeter on like this one. It is also same process. Just continue here. It's coming to cell. This one also coming to cell. You can say this resistance here. What's going on? There's no current here, so you can just ignore it. You can just carry on and come here. This is not 0. This is voltage of battery. Same thing. All right, it's taking time, huh? Tricky questions taking time. Let's continue with next one. Last question for today. Please try. You have identical resistance X and Y, and then you have identical battery. Let's just double check. All light bulbs are identical. Yes. EMF of batteries same. Okay. Yeah. Same batteries, same resistance, but different connection. What they ask you, the power in bulb X is P. What is power in light bulb Y? Okay. Today we are busy with X and Y. Okay. Please try. You have 30 seconds now. What is power on Y? If power on X is P, what is power on Y? This is our question. Just check. Let's continue. When time is over, we are going to answer this question, and then we have done for today. I hope it's going to help you, this lesson. These lessons will help you just improve. Yes, we can just remove it. Yes, let's continue. All right. So, for this kind of circuits, what we know? We know we have same current and they are sharing voltage. They are sharing voltage. We should remember for this kind of circuit, same current and sharing voltage. If we have 2 volts here, they are sharing by V and V. And write it down again. And then in parallel, what we have same voltage. Very important. We should remember. And then they are sharing currents. So if you have same resistance, also current also will be same. But if you have different resistance, current will be different. But voltage always same. All right. Please remember that. So just use this information. If I say 2V for battery, why I'm saying 2V? To make it easy. So you can say another. You can give another number. It's fine. If you have 2V, they are going to share by these 2 resistance. So voltage for X is V. Voltage for X is V. Okay, let's write here. Voltage is V. And voltage for other one is also V. They are sharing voltage. We don't need this one, just right. So when you come this side, in parallel, we have same voltage, 2V and 2V. I hope it's clear. So from now, I'm looking for power. What was the power formula? Power equals current times voltage. But what else we know? We have same resistance. Let's say R. We have R for X, R for Y. So let's calculate with X first. For X, what we don't know about I, so we can write for I, can write V over R. So V over R for I times V. So power for X, P, it was P, right? P equals V square over R. Okay, just keep it here. And then let's continue with Y. So for Y, what we have, power equals, just use this, okay, power equals current times voltage. This is our formula first. And then for Y, what is our current? 2V over R, right? Because voltage is 2V. So 2V over R. What is voltage for Y? Also 2V. You can write 2V. And writing 4V square over R. What we know about this? This is power of X. So if I say power for Y, let's write Y here. Y. So 4 V is equal to P, so you can write 4P then. All right, 4 times. You can, if you say it is difficult for you, P, Y, what's going on, you can use numbers. You can just give as just numbers. Let's say you have 10 volts here. Okay, and then you have 10 volts for battery. And then let's say we have 1 ohm. To make it easy, use just 1 ohm resistance. Resistance equals 1, and then resistance equals for Y also, let's say R is equal to 1 ohm. What is voltage for X? 5 volts, because sharing by these two. 5 volts we have, and then for this side, what we have? We have 10 volts, because voltage is not sharing for parallel, they are equal. Now, so let's calculate for X first. Even I can get current now. What is current for this? From Ohm's law, V over R, V is 5, R is 1, and then 5A. So current is 5A. So power equals I times V. Current is 5, and then 5A, yes. Voltage is 5. So P equals 25 watts. You know that, unit of power. Just giving numbers. For this side, what's our current? 10 over, so let's use Ohm's law, V over R, 10 over 1. Current is 10A. So current we know, voltage we know. We can calculate for PY, current times voltage. So just use formula PIV first. Okay, let's write PIV first one more time. This is our formula. And then PY equals, what's our current? What we calculate? 10. 10 times. Voltage is 10. And then what I'm getting? 100 watts. So how many times bigger? 4. Because 25 to 100, we should use 4 times. This method also you can use to answer this kind of questions. Good luck. See you next lesson. We are going to continue with long questions next lesson. So today just we answer multiple choice questions with you. And then next period we can carry on with other questions, long questions. Our answer is D. Thank you very much. See you next lesson. Please stay with us. Don't forget to something. You know what you are going to do. All YouTubers just saying something, but we are teacher. We are forgetting to say that. But you know what you are going to do. Thank you very much. See you next lesson. Maybe my son will say something. What we are going to say.
Teacher. Don't forget to like and subscribe to this video. Thank you.
Thank you for watching. See you in another video with a different question. Question-wise learning is the best. And remember, practice makes perfect.